Hey, Samantha. Happy Wednesday. Hey, Gumby. Yeah, it did. Hey, man. Sorry, I was over extricating Sock because the kids fell asleep and had dogpiled on her.
Bullshit, I can't hear you. Sound off like you got a pair.
I fixed the microphone. I didn't unmute myself for whatever reason. Pro Stremmer. Anyway, what I was saying was, what's up, everybody? That's just kind of how today went. So I had another power outage. That's why nothing was set up. It took me a little bit longer to get the stream booted up. And then I was just, I don't know why, for some reason, just beat down. So I fell asleep before the stream, woke up, and I was like, oh crap, kind of saw what time it was. All right, why is this thing not working? Okay. Everything's like half working. That's why I never shut the computer down. Once it's working, like, no touchy. Okay, good. All that's back up and running now, I think. Is it? Yes, yes it is. All right. I think I got everything. Cool. Cool. I read something odd, but nobody's talking about it in the news. There seems to be an absence of a certain ornithological piece. A headline regarding the mass awareness of a certain avian variety. Have you not heard? It was my understanding that everyone had heard. I got you, Gumpy. Or Bobby, I got you, Bobby. And now my chair's broken. Everything that can go wrong is. I was looking around looking for peaches. It's just one of them nights, man. Yes. I'm aware that the bird is the word. I am. Oh, man. It's going to be one of them nights tonight, isn't it? Just from the first, just 2 minutes of the stream, you can tell it's going to be one of them nights. That's all right. We're still going to crush it. Anyway, I hope you guys have been having a wonderful day. I think I also was talking about that earlier, and that's basically it. Oh, I did see a really cool piece that I'm looking forward to. We'll cover this one a little bit later, give people some time to filter in. But the guys over at Dreadnought just dropped this today, and it's a custom. I don't know if they fine-tuned it or they trained it from scratch, but it's a new language model that they've got set up for agentic pen testing. Ooh. So I wish I had known they were going to do this beforehand. It just came out today. Maybe I would have reached out to him. But that's okay. We got lots of stuff. The good news is Bad Sector Labs is also back up, which is great because I didn't have a lot on the docket for some reason. The news segments this week that I had, that I was bookmarking, pretty skint. Pretty skint. But that's okay. It's just these couple right here. The camera's kind of jacked up, is it? It might be from the blue. Is it jacked up? I don't think so. I think that's just the shirt. Actually, I found out there is something in the camera I do need to go fix anyway. Let's see. Let me take a look at what we've got over in the Bad Sector Lab side. Actually, take a look. Let's look at one of these other ones. This one is actually really funny. This one, FBI stymied by Apple's lockdown mode after seizing a journalist's iPhone. So because the iPhone was in lockdown mode, CART, whoever CART is, could not extract that device. The use of biometrics allowed the FBI to work into her work computer. So she applied her index finger to the fingerprint reader the laptop unlocked. So while convenient, biometrics should not be used as a potential target if you're a potential target of device seizure. So it would be interesting if there's a distress finger feature that could be used to prevent any future biometrics from working. Oh, I love the idea. So if you're not familiar, typically what you'd have on a computer is you'd have something like a password on your phone. Some of the operating systems do it, not necessarily all of them, But you can have a distress code in there. Same thing with like an alarm in your house, right? Where if somebody is forcing you to go disable it, you put in the distress code instead of that one. It has an alternate effect. Looks legit, has an alternate effect. I love the idea of a distress fingerprint. That'd be awesome. But I want to take a look at this one first. Let's go see. What are our feds doing now? Hey, Legacy, what's up, dude? All right, let's hop into some news here. So, FBI stymied by Apple's lockdown mode after seizing a journalist's iPhone. So, Post reporter was compelled to unlock MacBook Pro with the fingerprint, however. So, the FBI has so far been able to access data from a Washington Post reporter's iPhone because it was protected by Apple's lockdown mode when agents seized the device from the reporter's home. So, FBI agents were able to access the reporter's work laptop by telling her to place her index finger on the MacBook Pro's fingerprint reader, however, and that occurred during January 4th search of a Virginia home of the reporter Hannah Nathanson. Now, it's interesting that they had this happen because they specifically have said that passwords, no, I take it back. Passwords you cannot be compelled to provide, but biometrics you can be compelled to provide. I was almost thinking of that backwards. So the FBI executed a search warrant on Nathanson's home as part of an investigation into a Pentagon contractor accused of illegally leaking classified data. FBI agents seized an iPhone 13 owned by the Post, a MacBook Pro owned by the Post, and another MacBook Pro owned by Nathanson. Also a 1 terabyte portable hard drive, voice recorder, and a Garmin watch. So government investigators want to read Nathanson's signal messages and were able to view at least some of them on her work laptop. Porter also said she had a contact list of about 1,100 current and former government employees in Signal, which she used for encrypted chats. Go Signal. So the Justice Department described the search in a court filing that was submitted Friday in the U.S. District Court for the Eastern District of Virginia. This was according to 404 Media. Wait, did they already have a? I like 404. Hold on. If 404 has this, I think I'd rather read it from them. Because I like 404 Media a whole lot better. Actually, hold on. I take it back. 404, you've got to subscribe to it. I'm not subscribed to it. Never mind. I do like 404. They're good. I should probably go get a subscription to them. Anyway, so continuing on. The government filing opposes a motion in which the Post from Nathanson asked the court to order the return of the seized devices. So a federal magistrate judge previously issued a standstill order telling the government to stop searching the devices until the court rules on whether they must be returned. The iPhone was found powered on and charging, and its display notes the phone was in lockdown mode. So after the seized device was taken by the FBI's Washington field office, the computer analysis response team, that's what CART is, I couldn't remember what it was, began processing each device to preserve the information. But if you're not familiar with lockdown mode, it kind of throws a big monkey wrench in that. Password committed to memory, it can't be compelled to be provided. However, a password that is committed to biological memory, it can be that's compelling. I know, right? So I think it's bogus. You shouldn't be required to submit. What is it? They should not be able to compel you to give biometric unlocks. I think that's bullshit as well. Oh, the lurk is still broken? Dang it. Well, everybody gets one. Let's see. I was wondering why it played the pewter sound.
What, your mom buy you a pewter for Christmas?
There it is. Burning keys on certain fingers. Or a follow-up secret action has to be completed not to burn keys after fingerprint scan. Yeah, exactly. Just get one of those big orbs like in Men in Black. He put all of his fingers on there and just erased his fingerprints. Now, one thing I find interesting, I'm trying to think about this. So she had 2 MacBooks, one personal, one for work, and she had a iPhone. The iPhone itself was in lockdown mode. However, there was no equivalent to that for the MacBook. So if there had been some way to trigger them, and occasionally a MacBook will just dump your biometrics, or it won't dump it, but it will force you to go put your password back in to unlock it. So I wonder if there's a way you could kind of like connect those two. That's funny, Hats. That's really what you're working on. Let's see. All right, so going back to Apple made their lockdown mode for people at high risk. God, I'm just on a struggle bus tonight with everything. So CART, what was that? Computer Analysis Response Team. So CART couldn't get anything from the iPhone because the iPhone was in lockdown mode. The government also submitted a declaration by the FBI Assistant Director Roman Rojavsky that said the agency has paused any further efforts to extract this device because of the court standstill order. FBI did extract information from the SIM card with an auto-generated HTML report created from a tool utilized by CART, but the data contained in the HTML was limited to the telephone number. Yeah, you don't really get much from SIM cards these days. The idea of storing data on your SIM card is fairly dead. Apple says lockdown mode helps protect devices against extremely rare and highly sophisticated cyber attacks. It's designed for the very few individuals who, because of who they are or what they do, might be personally targeted by some of the more sophisticated digital threats. And it was introduced in 2022. Lockdown mode is available for iPhones, iPads, and Macs. Oh, see, if she had put her laptop into lockdown mode, maybe she'd have not gotten her stuff taken. It must be enabled separately for each device. To enable it on an iPhone or iPad, a user would open it in the settings and tab, yada, 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 turn on lockdown mode. The process is similar on the Macs, though. It's in the settings menu and can be accessed via the Apple menu. When lockdown mode is enabled, your device won't function like it typically does. To reduce the attack surface that potentially could be exploited by a highly targeted mercenary spyware, certain apps, websites, and features that are strictly limited for security, and some experiences might not be available at all. So it really strips down what you're working with in there. Lockdown mode blocks most types of message attachments, blocks FaceTime calls from people you haven't contacted in the past 30 days, restricts the kinds of browser technologies the browser can use. I didn't know that part, actually. Limits photo sharing and imposes other restrictions. It's funny that it limits photo sharing because that's how they've been popped before. There was an exploit in iMessenger it was a zero-click exploit around sending images, if I remember correctly. Users can exclude specific apps and websites they trust from the restriction if they want to, though. Yeah, it's redacted. I got it. I save all the things on the SIM card. Gumby, you're such a troll. I really thought you deleted Service Host EXE earlier today. I was like, no, he didn't. For a little bit of backstory for everybody, Gumby was venting his frustrations about Windows, and I was explaining to him why there's multiple Service EXE processes running on the computer. Essentially, it's a shell for actually running other processes in the background. So it all looks like Service Host EXE. And so you're just telling me, that's fine. You can just delete that out. And he trolled me back real good because I thought he actually did. I was like, please tell me, say psych right now. All right, so what about this? The reporter's fingerprint unlocked their laptop, though. FBI agents had more success getting into Nathanson's other devices, though the Justice Department complained that Miss Nathanson misled investigators about the devices that were seized. She misrepresented to officers that the device could not be unlocked with biometrics, possibly in order to prevent the government from reviewing materials within the scope of the search warrant. Rojavsky declared. Rojavsky. That's what I think I'm saying. I'm saying that right. That's the FBI guy. The Rojavsky declaration said that during the home search, FBI agents advised Nathanson that the FBI could not compel her to provide her passcodes, but the warrant did give the FBI authority to use Nathanson's biometrics, such as facial recognition or fingerprints, to open her devices. Yeah, by the way, so if you have face unlock, they could just say, hey, yeah, by the way, look here. You're going to be compelled to do it. Fun fact, though, that doesn't work if your eyes are closed. Nathanson also stated that she did not use biometrics on her devices. Well, she did at least on her laptop. Natson's Nathanson's. Nathanson's personal MacBook Pro was powered off when it was found by the FBI agents. The Post-owned MacBook Pro was found in a backup in the kitchen. What does that mean? Oh, in a backpack. I can't read. So the second MacBook that she had from the Post was found in a backpack in the kitchen and was powered on and locked. So that was the issue there. If she had powered it down or suspended it, I forget how you have to do it, but it will require you to actually put in your password when it comes back in. FBI said an agent presented Nathanson with their open laptop and assisted her. I'm sure they really did. In unlocking the device with her finger. The declaration described as follows. Nathanson was reminded that the FBI has the authority to use biometrics to unlock the laptop. Nathanson repeated that she does not use biometrics on her devices. Nathanson was told she must try in accordance with the authorization in the warrant. The FBI assisted Nathanson with applying her index finger to the fingerprint reader, which immediately unlocked her laptop. RIP. So in 2024, a federal appeals court ruled that the Constitution's Fifth Amendment protection against self-incrimination does not prohibit police officers from forcing a suspect to unlock a phone with a thumbprint scan. The case involved a traffic stop rather than a home search warrant, though. Yeah, so by the way, a lot of the phones nowadays, if you're ever really concerned about this, you can either hold down the power button or spam the power button 5 times, and then a lockdown mode prompt will appear on your phone, and then boom. So what that does is it's not as good, right? One thing it does is it disables biometrics. So then they can't force you to use your biometrics because the phone's in a state where the biometrics will no longer work. However, you got to get to that point first. So you'd have to do it in some time. Oh, I know there's like 5 Discords open right now, Bobby. It's because Discord is hot garbage in every way possible. We're not talking about Discord tonight. Just know that there's big mega like age verification drama going on with Discord. And let's just say I will not comply. If you could delete servicehost.exe and still have functional Windows, you deserve a Nobel Prize. Yeah. And so I was like, no way, it's still running. So if the Fed's going to get you and you have face unlock, piss them off so they beat you before they have a chance to unlock the phone. That's what I'm saying. Or if you're really committed to the bit hats, you just start wailing on yourself. I wonder how bad your face would have to get beaten for that to work. I have no idea, man. I know who you are, Gumby. Cut me some slack. I did not bring my A game tonight, so I'm going to apologize in advance, everyone. Let's see. What else did the FBI have to say? The FBI has so far been unable to obtain a physical image of Nathanson's work laptop, but did make a limited partial live local image, according to the government filings, and said that Nathanson's signal chat messages were set for auto deletion, so FBI agents took photos and made audio recordings of the chats, but the government filings said this was done only for preservation purposes and no substantive review has occurred. FBI apparently hasn't gotten any data from Nathanson's personal computer because the password is password protected and encrypted with no imaging could be affected to it. FBI paused any further efforts after the court standstill order. The government said it processed data from the voice recorder and a 1 terabyte hard drive, but it hasn't reviewed the data yet. The Garmin watch wasn't processed before the court issued the standstill. Okay. I wonder what information they can pull off of that Garmin watch. And also, I don't know about Garmin's, but like my Pixel watch, it doesn't have a biometric unlock. As soon as it's removed from my wrist, that's it. You have to. It's a what is it? It's a pattern unlock. Let's see. What about this? So FBI read signal messages on a contractor's device. So the investigation's target is Aurelio Perez Lagunes. I don't know how you say that. But he was a system administrator in Maryland who had top secret security clearance and was arrested after being accused of taking classified intelligence reports home. Justice Department said Washington Post article contained classified information from the report and that The government should be allowed to review the Post reporter's seized devices in preparation for Perez Lagun's trial. The government said that it was able to read at least some of the signal messages by reviewing Perez Lagun's device. Prior to his arrest, the FBI consensually reviewed messages between Mr. Looks like legumes. But between Perez and Nathanson sent via signal on or around January 7th, 2026. The messages discussed the classification level of certain documents, set forth details about which U.S. government agencies had produced different reports, and explained how certain documents would be referenced in forthcoming news articles. And all that's according to the Justice Department again. The Post argues that a wide-ranging government search of Nathanson's various devices violates the First Amendment and that the government's legitimate interests could be satisfied with a more limited subpoena. And the government claims in response that the Washington Post wants the court to reimagine the First Amendment as a journalist's exception to search warrants. Not sure how I feel about that. Lagoons. It looks like legumes. Like he's a peanut. Let's see. All right, where did we leave off? Right here. All right, so under the reasonableness standard of the Federal Rule of Criminal Procedures, 41, Section G, government is entitled to maintain this evidence because it is relevant to an ongoing investigation and prosecution, according to the Justice Department. In addition, the government cannot be reasonably required to hand over to Movant's devices that the government has probable cause to believe contained a highly classified information. Wait, who's Movant's? Did I miss something? Who's Movant's? That's the only time that word appears in here. Anyway, government said the Post suggestion of a subpoena for specific information on the devices ignores the obvious risk that evidence could be lost either through a failure to preserve expiring signal messages or bad faith conduct. Nathanson's false claim that she did not use biometrics suggests that the Post and Nathanson can't be trusted to preserve documents. The record confirms the correctness of the government's choice to proceed with a search warrant. Yeah. That's, again, Justice Department. The Post/Nathanson motion was supported in a brief filed by the Reporters Committee for Freedom of the Press. FBI seized electronic devices that contain Nathanson's most sensitive work product alongside confidential communications with her sources. Only a fraction of the information of that the department seized is even imaginably relevant. God, I'm struggling so hard. Only a fraction of the information the department seized is even imaginably relevant to the stated basis for the intrusion. So the leak investigation of a government contractor who's already been identified, charged, and arrested. Yeah, but I'm going to tell you this. I understand that, and I probably agree with them, but there's also a reason why in federal court, the feds have a 99% conviction rate. It's because they don't go small, they go big. The brief urged the court to stop federal agents from searching through unrelated news-gathering materials and doing irreparable damage to the confidentiality on which effective reporting demands. So, there we go. If you feel like you're going to be the target of a nation state, which the feds count, use lockdown mode. Oh yeah, not sponsored by Jocko yet. I can't even say freaking Jocko. I don't know what's going on with me. I slept good last night too. Like, this was bogus. Let's see here. What else do we got up real quick? What was Redmond? Oh, Redmond is another agentic red team framework. So this was a cool a neat tool that I had bookmarked. I haven't looked at it yet, but it looked kind of interesting. I wanted to take a look at it. So Redmond is an AI-powered agentic red team framework that automates offensive security operations from reconnaissance to exploitation to post-exploitation with zero human intervention. Legal disclaimer. Don't do bad stuff with. I like the idea of the interface here, though. Let's take a look. Let's watch the video here real quick. What do we see? Nice little visuals here. Hold on, I gotta look at something real quick. I'm not gonna try them for this, but who are the contributors? No contributors? Okay. I wanted to see two things. One, was there a Claude.md? Because, first off, the reason I said that is because the interface actually looks really sharp. And most people that are good at programming these kind of back-end systems might not be the best at programming these UX systems. And the UX actually looks pretty sharp. I like this. This is cool. This is a bit something like I had kind of envisioned for Hackbot. So, got a neat little diagram here. Running Metasploit. Top tier, super elite, Metasploit. He's got a human in the loop setup here, so phase transition request. SSH session 1 is active, need post-exploitation. You said no human intervention. That's a human in the loop, sir. False advertising. This reminds me of a current curl kerfuffle. Full auto agents is a bit iffy. Yeah. And so for anybody who's wondering what Hats was talking about, curl is, I think, completely ending their bug bounty program. And the reason is because they were getting flooded with AI slop, PRs, and bug reports that were not legit, didn't come into effect, and just completely burned the maintainers of curl. And I think it's funny because everybody's really sad about curl coming up with that, but nobody really gave a damn about FFmpeg coming up with that kind of stuff. So, now I think there is a little bit of a difference to that story, though. FFmpeg actually did have the vulnerabilities. Curl didn't, and they were complete false positives. But there's going to be a lot of open source projects that when they get submitted, they start getting flooded and basically crushed to death by a flood of AI generated, poorly put together, or sometimes not at all, really just slop that's going to come in and they're like, hey, I made a PR to fix this issue. And it's like actually not an issue. And there's all sorts of other weird stuff to it. It's going to be exhausting. Anyway, this Redmon actually looks pretty cool. Hey, I didn't know about that.
Incoming transmission from Marano Gumby. Got to reboot my computer. It lagging hard. It taken me 10 minutes to type this text.
Damn, dude. Yes, you did the reboot. I like this though, looking at it. So this is completely designed to run inside of Docker. I like the idea. Maybe I'll go steal some ideas for Hackbot. I want to keep working on Hackbot because I like it. I like the idea of it. Although I can already see. So Hackbot, speaking of which, since I know we've been working on the C2 interactions, Hackbot is going to have a huge redesign after we finish the post-exploitation and stinker agents. Because after seeing where things have gone, right? Because Hackbot started when agentic systems were kind of like new, right? And I work on it really, really slowly because I only work on it on the stream. So as we go through and we start working on Hackbot some more, after we finish Stinger, it's going to be a mass rewrite because it's going to be completely different. I think we're going to basically use a generalized agent to handle a lot of those issues as they come through. Let's see. I like this though, because basically you clone it, you set up your env file, boop, boop, and get it going. Now hold on, let me look at the Docker file real quick. Well, because he was saying, do Docker compose? Yeah, so what's in his compose here? Because I'm curious. What services do we have? So he's got a Postgres database, Neo4j, Recon host, Recon orchestrator, a Kali sandbox. Okay. Whatever agent is. Which I'm guessing that's actually running his local agentic code. Yeah, mapping that over to his app. What else do we have here? There's the front end stuff. Web app. network. Cool. Augusta. Actually, this was kind of the approach I was thinking about taking with Hackbot. I like it. It looks kind of cool. Wonder what kind of control it actually has over. So I like this. So he's got a reconnaissance pipeline, 6 sequential scanning phases that map your target's entire attack surface, from subdomains to vulnerability detection, stores it in a rich queryable graph. I do like graphs.
Incoming transmission from
Hey, Max.
Zombie. Okay, I'm back on watch.
Welcome back, Abe. Welcome back. Poor FFmpeg. Anyways, better fix y'all shit because we all depend on you. That's right. It's like the old XKCD meme, right? It's like the entire infrastructure of like multi-billion-dollar companies are being held up by like one little block of some dude thanklessly working on a project from a cornfield in, you know, Kansas for the last 30 years. That's pretty much it. Let's see. I love this idea though. I think this guy put a lot of thought into how he's going. So his AI orchestrator is Langgraph-based autonomous agent. Langgraph, nice. Get some. I do like Langgraph. Langgraph-based autonomous agent that reasons about the graph, selects security tools from an MCP, transitions through informational exploitation and post-exploitation phases, and can be steered via a real-time chat. Nice. Nice. I want to spin this one up and try it. I have everything that's needed. I think the only thing I'm actually missing is... Where was it? NVD API key. I think that's the only thing that's missing out of here. Let's see. Nope, that didn't bring it up. Nest NVD API. He's saying you need this API key. Hold on, let me move this over here. NIST.gov/developers. But that one's not found. I'll have to go see what, maybe go look at it and see where he's actually referencing this. Hang on. Let's go check the Compose real fast. Let's see. Docker Compose. Where's he using that? So he maps that into the Recon Orchestrator. Let me look at something real quick. I want to look at his orchestrator code. Recon Orchestrator. Let's see. He's not using that? No. Where are you using this at? CVE helpers. Oh, that's in... Okay, so he's using that in Recon. There we go. So where's this defined at? Here we go. Yeah, so that's the right one. Okay. So that is the correct API that you would need. Do you not need an API key for it, though? Interesting. All right, I don't want to go too far down that rabbit hole. I just thought that was neat that I was like, I have not seen that. And the whole reason why we were using Nmap the way we were is to get that NVD data. All right, let me look at something here. So I love his idea, though. So Recon Pipeline, AI Orchestrator, Attack Surface Graph, Neo4j Knowledge Graph, 17 node types, 20 relationship types that serve as a single source of truth. Now, one of the downsides, so I have a lot of experience working with attack graphs because I've used Bloodhound a ton and really dug into it. Hey, Devil, what's up, man? We're also on Twitch and YouTube, bro. So, and also, if nobody's on, I'm just talking to myself. I do that all the time. But dude, feel free to ask questions. You've literally got like the megaphone over there on Kick. Let's see. But yeah, this looks pretty cool. Oh, so Del, answer your question. What we're doing is we're going through hacker news for tonight. Just checking this out. This was a neat tool though that came across my wire called Redimon. Redimon. I'm going to save this. I'll put this up on the GitHub list. We'll put this into AI machine learning security. I like that. Also, I'm going to put that under Hackbot references because I want to go see what he's doing. Oh, so what I was saying here is he's got a Neo4j database. I love the idea. One of the things that can be tricky with that, though, is building the queries for it, because I like the idea of it, but understanding attack graphs and building out graph databases can be very tricky, and that's why a lot of people don't do graph databases very well. And when they do it like for a very limited subset of data. So. Yeah, Devil, if you want me to check out some of them, feel free to send it over, man. All right. Anyway, so that looked pretty cool. Oh, hold on. I forgot. I was going to send that in the chat for everybody. So anybody who wants to check this out, play for it. It's pretty straightforward. You plug in your API key, you run a Docker Compose, and you're good. Let's see. I'm going to save this one for real quick because I want to go over this one real fast. So I did not even know that Anthropic had their own like internal red team set up. But yeah, this is from Anthropic's kind of red team. Evaluating and mitigating the growing risk of LLM discovered 0 days. So Cloud Opus 4.6 released today. Well, this is a little bit old. This is from February 5th. Cloud Opus 4.6 released and continues the trajectory of meaningful improvements in the model's capability, and also as well as for cybersecurity. Last fall, we wrote what we believe to be we're at an inflection point of AI's impact on cybersecurity. The progress could become quite fast, and now was the moment to accelerate the defenses on the AI side. So the evidence since then has only reinforced that view. AI models can now find high severity vulnerabilities at scale. Our view is this is a movement or a moment to move quickly. Empower defenders to search for such code pace, as much code as possible while the window exists. Opus 4.6 is notably better at finding high-severity vulnerabilities than previous models and a sign of how quickly things are moving. Security teams have been automating vulnerability discovery for years, investing heavily in fuzzing infrastructure and custom harnesses to find bugs at scale. But what stood out in early testing was how quickly Opus 4.6 found vulnerabilities out of the box without task-specific tooling, custom scaffolding, or specialized prompting. That's a bold statement. I'm curious to see what kind of evidence they supply for it. Even more interesting is how it found them. Fuzzers work by throwing massive amounts of random input at code to see what breaks. Opus 4.6 reads and reasons about the code the way a human researcher would, looking at past fixes to find similar bugs that weren't addressed, spotting patterns that tend to cause problems, or understanding a piece of logic well enough to know exactly what input would break it. Okay, I like this idea. Also, though, I mean, it's good, though. Don't get me wrong. There's a limitation here. You got to have source code. So this is going to work for open source projects, which is a great thing because a lot of closed source systems are derivatives from open source. Let's just be real about that. Licenses be damned. You don't believe me? Go look at, what were those? The TP-Link routers, where they finally had to open source it, and then everybody just started releasing their own custom firmwares. I'm curious how they're coming up with this, like, maybe, actually, okay, if they're taking the code approach here, where they're doing code analysis, that's cool, and I can understand that. It does clear up some of the logistics here, because I'm like, without custom prompting, doing some reverse engineering, as well as understanding, like, or maybe building a fuzzing harness, anything like that. I don't think the LM's going to get quite that far without some kind of guided prompting. But anyway, so when we pointed Opus 4.6 as some of the most well-tested code bases, projects that have had fuzzers running against them for years, accumulating millions of hours of CPU time, Opus 4.6 found high-severity vulnerabilities that had gone undetected for decades. Part of the tipping of the scales towards defenders means doing the work ourselves. So we're now using Claude to find and fix vulnerabilities in open source software. So we started with open source because it runs everywhere, and vulnerabilities there ripple across the internet. Many of the projects are maintained by small teams of volunteers who don't have dedicated security resources. So finding human-validated bugs and contributing human review patches goes a long way. And that was the crux of where FFmpeg was blowing up and crashing out on people, is because they were being submitted these bug reports and exploits with no potential fix. I was like, well, dude, if you can break it, you can go fix it too. Let's see what else. So far, we've found and validated more than 500 high-severity vulnerabilities. So we've begun porting them and are seeing our initial patches land. And we're continuing to work with the maintainers to patch others. God, can't talk. So in this post, we'll walk through our methodology, share some early examples of vulnerabilities Claude discovered, and discuss the safeguards we put in place to manage misuse of these capabilities to continue improvement. This is just the beginning of our efforts. We'll have more to share with it as it scales up. All right, so what was their setup? So we put Claude inside a virtual machine, literally a simulated computer with access to the latest version of open source projects. We gave it standard utilities like Python and vulnerability analysis tools for debugging and fuzzing, but didn't provide any special instructions on how to use the tools, nor did we provide a custom harness with what would give it special knowledge about how to find better vulnerabilities. Now, keep in mind, they're probably doing this through Claude Code, and in that case, it has a built-in search function. So keep that in mind. It's not isolated in its knowledge of what's baked into the model, which is a lot. It can go out to the internet and search for data. So that means we were directly testing Claude's out-of-the-box capabilities, relying solely on the fact that modern language models are generally capable agents that can already reason about how best to use their tools. So to ensure that Claude hadn't hallucinated bugs, good, we validated every bug extensively before reporting it. So we focused on searching for memory corruption vulnerabilities because they can be validated with relative ease. Unlike logic errors where the program remains functional, memory corruption and vulnerabilities are easy to identify by monitoring the program for crashes and running tools like address sanitizers to catch non-crashing memory errors. Because not all the inputs that cause a program to crash are high-severity vulnerabilities, we then had Claude critique, deduplicate, and reprioritize the crashes that remained. Finally, for our initial round of findings, our security researchers validated each vulnerability and wrote patches by hand. Oh, good for them. As the volume of the new findings grew, we brought in external human researchers to help with the validation and patch process. Our intent here was to meaningfully assist human maintainers in handling our reports, so the process was optimized for reducing false positives. In parallel, we were accelerating our efforts to automate patch development to reliably remediate bugs as we would find them. I mean, I think that's pretty cool. It goes right along with the story we were reading from, who was it? He's actually in this week's Bad Sector Labs blog. What was his name? Hey, Asion, what's up? Thanks for coming online. Let's see. Where was it? It was from Space Raccoon Sec. Hang on. Was that the one we were talking about? No, this was not the one I was thinking of. But there was another article we had read through that discussed that very same thing. Hold on, I probably have it here in the news thing. Where is it? I think it was this one from Blaise. Let me see. Was this the correct one? Sanity check over the wire. Let's see. No, this wasn't the one I was thinking of, but we are seeing a lot of research in here. I wish I could find it. One of them was a fellow that came up with, he was like a professional exploit developer. Like that's what he did as his day job. And he was talking about the pros and cons of the current state of language models as he was doing this. I wish I could. I'll have to go look for that article later. Oh, okay. I figured it was you. Cybersecurity student? Oh, nice, dude. We get a lot of cybersec students in here. Well, let's see. What else do we have here? All right, so let's look back at the article. Vulnerabilities. So here are three of the vulnerabilities Claude found and now patched by the maintainers, which we believe demonstrated unique advantages that the language models had over other tools. GhostScript is a utility for processing PostScript and PDF files. Claude initially went down several dead ends when searching for vulnerabilities, both attempting to fuzz the code and, after this failed, attempting manual analysis. Neither of these methods yielded any significant findings. Eventually, however, Claude took a different approach, reading the Git commit history. Claude quickly found a security-relevant commit and commented, "There's a commit about stack bounds checking for blend values. This is related to font handling. Let me get more details on this commit." From there, Claude could understand what had changed.
Hear you. Sound off like you got a pair.
Kelly, you're full of crap. What's up, man? Anyway, hold on. So from here, Claude took a look to understand what had changed. So the commit shows that adding stack bounds checking suggests there was a vulnerability before the check was added. If this commit adds bounds checking, then the code before this commit was vulnerable. So to trigger the vulnerability, I would need to test against a version of the code before this fix was applied. With this in mind, Claude then looked at other places where the function was called in order to find potentially similar vulnerabilities that were left unpatched. Nice. And that's a very valid approach. Very valid. I've seen a lot of my buddies who are like professional bug hunters go through and do that. So then Claude continues, let me check if maybe the checks are incomplete and there are other code paths. So let me look at other callers in this particular C file. Aha, this is very interesting. In this C file, there's a call to blend, and it does not have the bounds checking that was added. Ooh, nice. That's pretty cool. So after making the observation, Claude quickly constructed a proof of concept crash, and it proved it was prediction. Nice. Very cool. I'm on a trip to Vegas. Daughter turned 21 and wanted us to come along. Aw. Dude, first off, congratulations on being such a stellar parent that you got a child at 21. That is freaking great. Second, that's really cool that she wanted you to go. When I was 21, I did not want my parents there for that celebration. No. That honor fell to the brother that's closest to me. And so him and his friends took me out and got me thoroughly destroyed. I laid down the gauntlet and they absolutely obliterated it, and I admit I was wrong. Let's see. What about the next one? So the next vulnerability that they found, it was in OpenSC. This is a command line utility to process smart card data. Claude initially attempted to find vulnerabilities by fuzzing, and after that failed, by manual analysis. As before, when that didn't work, Claude took a different approach. It began to search the repository for function calls that are frequently vulnerable. So Claude said, let me look at where the URL is used, specifically the standard archar and the strcat operations, which could potentially have path reversals and buffer overflow issues. Claude quickly identified a location where multiple stringcat operations were in use. The functions are typically viewed as unsafe in C because they allow for concatenating strings without any checks on the length of the resulting concatenation. So it's therefore extremely important that the programmer verify the output buffer is long enough to contain the concatenated input. And the key issue was, here in the code. Buffer size was defined at 4096. And Claude identified this vulnerability had a buffer overflow. Nice. That's pretty cool. See, so when we look at the statistics for how frequently this line of code was fuzzed by existing fuzzers, we see that this line of code is infrequently studied by traditional fuzzers because of how many preconditions are required. In contrast, Claude was able to reason about the code fragment where interesting and focus its effort instead of indiscriminately studying all the lines. Nice. Intelligent fuzzing. Oh yeah, Robo was there that night. I forgot about that. Hey Robo. What's up, brother? Yeah. The last clear thing, I don't know if I ever told you this, Robo. The last clear thing I remember about that, which was Oh my goodness. That was 20. Hold on. That was 26 years ago, bro. Damn. I'm old. But yeah, the last thing I remember is we're at the bar, we're drinking, and watching the Mavericks game, because we live in Dallas, right? And I remember a basketball being passed to somebody, and that basketball just freaking goes into bullet time all of a sudden, just shoo. I'm like, whoa. That was the last clear memory of that night that I have. Everything after that is just a blur. All right, anyway, back to the article. What was the third vulnerability they found? CGIF. That's a library for processing GIF files. So in this case, we were surprised not by how Claude found the bug, but how it validated the bug and produced a proof of concept that proved the vulnerability was real. Ooh. So briefly, Claude found the library assumes compressed data will always be smaller than its original size, which is normally a safe assumption, and that this assumption could be exploited. The way it did this was challenging. The GIF file format, it is pronounced GIF. If anybody pronounces this as GIF, I'm going to throw a jar of peanut butter at you and tell you that's GIF. Anyway, so the GIF file format compresses data with the LZW compression algorithm. Unlike traditional LZ77-backed compressors that encoding matches with a distance and length pair, LZW builds a dictionary of frequently used pairs of tokens, and then when the compressor encounters this token a second time, it can output a shorter bit string indicating output this token again. So for those familiar with the language modeling, LZW is very similar in spirit to the process of BPE tokenization. I'm not familiar with that, but I'll take your word for it. CGIF had implicitly assumed that the compressed size of a compressed string would always be less than its uncompressed size. Funny enough, yeah, there are some weird compressors out there that they don't do that. The compressed data can actually grow in size. But Claude immediately recognized the vulnerability here. So Claude comes back and says, to trigger the overflow, we need small number of pixels, which is a small image, and many LZW codes written. The pattern that generates most LZW codes is one where no compression happens, each pixel becomes a code, and many resets occur. Okay, so with the palette of 4 colors, which indices 0 to 3, dictionary fills up after max dict length of 4096 entries. Reset happens when the dictionary reaches 4096. So to trigger the overflow, you set your number of pixels to n, buffer size to n plus 2 codes, and we generate n greater than n plus 1 codes. So each pixel can generate 1 code plus resets. Interesting. Now what's cool is, I mean, this is something that frickin' Claude splat out, so that's pretty cool. I do have to be honest, and you guys probably know this, but as I have worked with multiple language models, I've never really been a fan of ChatGPT. I just didn't really ever vibe with it. Grok is pretty cool for some use cases, but I don't like going through a chat interface. Really, Grok is kind of like my default search engine for the internet. It does a very good job of searching and finding sources. Claude is really a good mix of everything. It does a pretty decent job at logic. It does a pretty decent job at coding. It's pretty good at searching the internet. That's the one I tend to gravitate towards the most. I hate that Blaise is about a year younger than me. At some point, I'll have to invert gravity manipulations to fix that. Do it. Do it. Because technically, if you could invert gravity, you could travel back in time. Let's see. Anyway, so after all this reasoning that Claude did, essentially what it's saying is, it's going to try to create a GIF where all the pixels cannot be compressed. So I'm guessing every pixel is going to be small with limited resets to it. So Claude recognized that LZW maintains a fixed size symbol table. So it was possible to max out the size of the symbol table. The LZW inserts a new special clear token in the data stream. And then this results in the output compressed size exceeding the uncompressed size, triggering a buffer overflow. Huh. This vulnerability is particularly interesting because triggering it requires conceptual understanding of the LZW algorithm and how it relates to the GIF file format. Traditional fuzzers, even coverage-guided fuzzers, struggle to trigger vulnerabilities of this nature because they require making a particular choice of branches. In fact, even if CGIF had 100% line and branch coverage, This vulnerability could still remain undetected. It requires very specific conditions or a very specific sequence of operations. Cool. Let's see. What up for... Okay, so now they're going to talk about what safeguards they put in after doing this research. So alongside the release of Claude Opus 4.6, we introduced a new layer of detection to support our safeguards team in identifying and responding to cyber misuse of Claude. So at the core of its work are probes, which measure activations within the model as it generates a response and allows us to detect specific harms at scale. Hold on, let me reread that because that's interesting. So at the core of this work are probes, which measure activations within the model as it generates a response and allows us to detect specific harm at scale. Hold on. I haven't seen what they're talking about with probes here. When was this released? Hold on. I want to say I would have seen this blog article. This is another one from Anthropic where they're talking about basically cost-effective monitoring and reclassification for identifying jailbreaks. Interesting. Anyway, so what it sounds like what they're saying is when they say measure activations within the model as it generates a response, it sounds like they're almost measuring which input-output vectors are being triggered. Like they're tracking the data as it goes through. Interesting. I want to know more about that. I would like to know more. So with this launch, we've created a new cyber-specific probe to better track and understand the potential misuses of Claude in the cybersecurity domain. So on the enforcement side, we're evolving our pipelines to keep pace with this new detection architecture. This includes updating our cyber enforcement workflows, take advantage of the probe-based detection, as well as expanding the range of actions we take to respond to cyber misuse. In particular, we may institute real-time intervention, including blocking traffic we detect as malicious. This will create friction for legitimate research and some defensive work, and we want to work with the security research community to find ways to address it as it arises. So we're committed to keeping Claude as the forefront of cybersecurity by working hard to make it both safe and effective. Safe and effective. Together, these changes represent a meaningful step forward in our ability to prevent misuse, not just in what we can detect, but in how quickly and effectively we can act towards what we find it. Now, I'm not surprised they're talking about this because you remember there was those scrub tier Chinese hackers that were trying to use Claude code with special prompts set up to go hack the planet, and they failed abysmally because one, scrub tier, two, they didn't know how to use something like OpenRouter or actually I think OpenRouter still technically routes over to the Anthropic backend. I think they're literally just a reseller, but they couldn't be bothered to set something like Bedrock. So, in conclusion, Opus 4.6, awesome. Found O-Days. Looking ahead, broader security. Language models are capable of identifying stuff. And we have ongoing mitigations. That's it. Pretty cool, though. Hang on, let me grab a copy of this URL here real fast. Because I want to note this. I'm surprised I put this one in here twice. I'm going to put that note in, and then this one I'm going to trash. There we go. There we go. All right. Now I need twice the gravity difference. Oh, because Gumby wants in on that action? Yeah. All right. This was a fun one. Hold on. I gotta nuke this out real quick. There we go. Better. Got the rest of my screen back. All right. So this is from the guys who are at Dreadnode, who I adore. They do some really great work. But this one is called Worlds, a simulation engine for agentic pen testing. I'm very curious about this. There we go. So what we did is we fine-tuned an 8 billion parameter model that went from spamming non-existent Metasploit modules to a full compromise of the game of Active Directory domain. Nice. We did this using a purely synthetic training data, no distilling larger model trajectories, no standing up 12,000 actual hosts, no aggregating customer data, no digital twins. By synthesizing network dynamics and tool mechanics, we were able to affordably and efficiently scale high-quality training data for any network configuration. Ooh, bold claims. Let me see bold evidence. So the capabilities that made this outcome possible is Worlds, which is a simulation engine that generates realistic penetration testing trajectories across arbitrary Active Directory networks, entirely on CPU, in seconds per trajectory. Nice. So these fine-tuning results are a proof point for what our customers will be able to accomplish with this system once it releases on our platform in the coming weeks. Nice. Maybe I can get them to come on and talk about it. The post covers why security's training data problems can't be solved with real infrastructure, how Worlds closes the sim to real gap, and what a model trained on this output can do to an Active Directory network. Hoo, daddy likes. Let's see. So small models appearing in the security domain. So we're big believers in the power of small task-specific models. I am too. I think they're going to be the biggest jump of everything. Don't get me wrong, I like the big, models, but if a smaller, very focused model can get a job done, I think it's great. Anyway, so on the article, security as a domain uniquely benefits from them. Not lugging 800 gigs of model weights into a network controlled over C2, living off the land models and inference models, lol ML. The benchmarks for an 8 to 32 billion parameter model are keeping pace with their frontier counterparts. Consider the story in software engineering. In October 2024, Claude 3.5 Sonnet set a new state-of-the-art on the SWE benchmark, verified at 49%. A year later, CatDev 32 billion parameter model hit 62.4% on the same benchmark. Qwen 3 Coder 30B achieved 50% with only 3 billion active parameters. And guys, by the way, 3 billion is tiny. 3 billion is... I wonder what A30B is. Is that ablated to 3 billion parameters? Because that's a tiny model. That's A30B instruct. I guess that is the right one. Hold on. Let's see what I want to look at this on Hugging Face real fast. So Qwen 3 Coder is available in multiple sizes. Today we're excited to introduce the 30B A3B Instruct. This streamlined model maintains impressive performance and efficiency, significant performance among the models for agentic coding, agentic browser use, long context capabilities with native support for 256K tokens, which could be extended up to 1 million tokens. Nice. So what is different about this model? What is this model? Well, typically, Gumby, like whenever you are looking at a model, right? So this one's Qwen 3 Coder 30B. Typically, that 30B means 30 billion parameter models, which roughly equates to how much, if it was in, FP8, right? That's roughly how many gigs it would be, right? And then you could quantize that down to try and cut that by percentages. So if it was Q1, you'd cut it by 12.5%. Q2, you'd cut it by 25%. Up to like Q4, which is usually what people consider to be, that's about as far as you want to go with it. You could get that to 50% the size. But I'm wondering what the A3B indicates in here. Am I logged into Cloud in here? I'm not. Hang on, I gotta look this up real quick. So I need to know what this A3B indicates in here. Oh, okay. I believe the... Hold on. So I believe it's 30 billion total parameters, but 3 billion active. Okay, so yeah, I was looking over at Grok real fast. It means active 3 billion parameters. It's a mixture of model experts with 30.5 billion total parameters, 3.3 active inference, activated per inference step. I mean, a 30 billion parameter model is pretty small. Typically, I consider a small language model to be something 10 billion parameters or less. So, okay, at full precision, so at FP16 for that model, you would need about 60 to 63 gigs. Full into 8, you would need 32 gigs. Like I said, because it's a 30 billion parameter model, I was trying to remember what they meant with this A3B. Not to go sidetrack, but this was a designation I hadn't seen before. I needed to know what it was. So anyway, back to the article. What he's saying is Quinn 3 coder with A3B achieved 50% with only 3 billion active parameters. So that means the total model weights is 30 billion, but only 3 of those get activated whenever it's running its inference. So today, much of the research is on how to build these outcomes in public knowledge, and small models are progressing faster in coding capabilities. So what about offensive security? So the training data problem is the primary bottleneck for creating small models to automate security operations, access to high quality environments and data. So much of it is siloed in private companies or unusable due to compliance. Software has GitHub. What about the security equivalent? It doesn't exist, pretty much. So using handcrafted labs, we built our pentest judge research around Game of Active Directory as an eval for reinforcement learning for our first offensive AI con presentation, which I saw that presentation. It was really cool. I liked what they did with it. Handcrafted lab environments like Goad are excellent for humans and testing agent mechanics, but each config is static, slow to stand up, messy to track, and difficult when reset. So given the performance of the best models, we've seen models solve it end to end in under 5 minutes. Goad and its variants are likely saturated as a benchmark and not easy to build meaningful variants on. So building the infrastructure from scratch means Windows networks are require specialized knowledge to configure, significant memory to run, and substantial cost to create the required data volumes. Windows networks are expensive to host on the cloud, and creating networks that mirror the number of hosts seen in enterprise networks and host them in parallel for reinforcement learning. This exceeds hundreds of thousands of dollars. It does, because most enterprise environments typically are going to be well in excess of 500 nodes on the network. So this is why most networks relied heavily on evaluation, CTFs, and online classes, top out of 5 to 20 hosts. So we're asking models to learn on the rare side of the distribution, which is a 3 to 5 node topology, and extrapolate to the vast majority of the distributions. So leveraging large networks, those are in the proportion to aggregate large network data are unable to use it due to distribution and usage restrictions. So you would have to be a service organization like an MSSP or a pen testing firm in a position to aggregate sensitive data. If you managed it, you've got data that's impossible to share, dangerous to work with, and still only represents a small fraction of the distribution of all the network models that you want. And when he says dangerous to work with, right, it's because you got to remember, whenever you're training a model, the entire document gets built into the weights of the model. So it is possible to go pull that data back out almost verbatim, right? So imagine you're a penetration testing firm and you have built a language model and you have trained it on, I don't know, all your pen testing data that you've collected over the last 10 years, right? Let's say you've been in business a while. Okay, cool. But anybody who's able to get to that model and misuse it could instantly start leaking customer specific data. And that's the biggest killer of a pen testing firm, because it immediately blows away all the trust that you have built. That's one of the big things that offensive security shops rely on, is trust from the customer. So no matter which way you try to work with real infrastructure, you simply can't generate thousands of variants at speed and scale required for meaningful training data. So barring inspiration from Google's DeepMind work on simulated environments, we gathered up our domain expertise and asked, what if we just built the data we wanted directly without any real network? Nice. I love the idea. I was really skeptical about training on synthetic data, but it seems that it gets worked out pretty well for a lot of use cases. So addressing the sim to real gap. Concept of using programmatically simulated computer networks to train security agents isn't new. For years, there's been dozens of reinforcement learning papers showing different models learning to perform penetration tests. Despite that research, there's really no product claiming to perform autonomous penetration testing before language models, or large language models. So the research papers had an agent performing in simulation instead of a model of the environment that was created. So not a language model that takes in tokens and spits out tokens, rather it's a simplified representation of existing objects. So just as Sims is a model of the real life, or Hearts of Iron is a model of military history. Ooh, never heard of Hearts of Iron. I'll have to go check that out. Security researchers have historically attempted to simulate network operations using partially observable Markov decision processes. Awesome. Anything that's got Markov in the name, I'm usually down for. Agents take actions with partial information about their environment, taking observations of that environment as they take action. So it's a reasonable mathematical model of real ops, yet it rarely results in agents that can be deployed into production. So the key to this problem is the size gap between simulation and reality. So otherwise known as the sim to real gap. All models are wrong, but there are two requirements for making one that's useful. Actions and observations in simulation must match reality. So instead of a scan host, a command that tells you whether a host exists and what services or ports are open on it, you have access to Nmap, which has subtler requirements around calling a tool and a wider variety of responses to interpret. So an agent learning to speak the simulation's tool language cannot be placed in a real-world harness unless the languages match. I mean, if you think about it, that's kind of what we were coming across with Hackbot, right? We took the tool language out and we made sure to put it into data structures. I just hadn't thought about it like that. I just wanted it to be simple, reusable objects in the code. So the second problem here is relevant and accurate state dynamics of the environment have to be modeled. So a large part of network operations is abusing Active Directory. So if Active Directory relationships aren't modeled, the distribution shift between the state dynamics of simulation and the real world would be so large that the actions of the agent knew how to take wouldn't be effective in the real world. And that's true, man. I'd be interested to know like how, I would love to see how this thing worked. Because there's been so many times when I have seen all the telltale signs that something should have been vulnerable to a particular attack or exploit or whatever, and it just would not work. Let's see. What else we got here? So a realistic world model for network operations and automated penetration testing. So Worlds is a simulation engine that generates complete penetration testing trajectories. It includes the full sequence of tool calls, observations, and reasoning an agent would produce when attacking an Active Directory network without ever provisioning a real host. Oh. So the first question we asked when designing Worlds was, what state dynamics are the most important to represent in modern network operations? Active Directory, of course, is a big one. It's common for networks with strong vulnerability management programs to be compromised by unintended results of their Active Directory relationships. Credential attacks, delegation abuse, ACL abuse, and ADCS abuse all stem from Active Directory misconfigurations. So a high-fidelity simulation of Active Directory dynamics were the biggest bang for our buck. So from a development perspective. The second was vulnerability scanning. So as Nmap and Nuclei both publish known ports and services and have CVEs associated with them. So the state dynamics themselves are straightforward to model given the graph nature of Active Directory, with strong candidates like AD-Synth built on top of other tools like AD Simulator. So we broke Worlds into two conceptual layers. This is so cool. These guys are freaking just geniuses. All right, so the first layer is manifests. Manifests are World's single source of truth, defining the bounds of the host service principles and the relationships. And this defines the diagram for our network. Manifests could be created from real-world networks using LDAP search or a collector, but to generate the thousands of variations required for training, we generated a probabilistic configuration. So this enables choosing a network and then having the vulnerabilities and specific qualities of the network generated probabilistically, making it easy to sample diverse networks. So on top of this, we layer in the misconfigurations we want our models to exploit. Curb roastable service accounts, AS rep roastable users, and excessive ACL permissions. So based on these configurations, we ensure that these relationships are valid and CVEs are accurately assigned to relevant hosts and services. Finally, we ensure that there is at least one valid path from a specific starting point on the network to compromise the domain. I love this. Oh, this is so freaking cool. I'm gonna have to hit them up because I had no idea they were even working on it. They've been so quiet recently. I was actually meaning to reach out to them and be like, hey guys, what are y'all working on? Just because usually they're very chatty and I hadn't heard anything from them. Oh, Hearts of Iron is a turn-based game just like Risk. Got it. These guys sound like they would be into those turn-based games from what I know about them. All right, so anyway, back to the article. This represents our relevant state dynamics. Everything layered on top of this is done to increase the fidelity of the simulation's ability to be useful learning signal for large language model agents. So there's some generative elements that we use in the environment that get used when an agent issues certain tool calls, such as enumerating file shares, for example. Relevant files can be generated and cached based on AD information. All right, so that's the manifest layer. The second part of this is the tool layer. So the manifest defines the state of the environment, but trajectories require interaction. So for LLM agents, we're interested in actions represented by realistic tool calls and their responses. So from the agent's perspective, this is all just text. It sends text formatted in a specific way to elicit a tool call and receives text back. Worlds creates an endpoint that takes in strings representing the contents of a tool call the way they might be written from the command line. And this might be an nmap command or an LDAP search or an SMB client, or even host-based utilities like whoami or cat. These tools are all text-based, so we can template out their responses with configurable values that can be filled in or casually generated by querying the manifest instance at runtime. Nice. So the arguments are passed and the manifest is queried to determine what the realistic output would be according to those templates. So in addition to the tool output, events are emitted based on whether this created new information for the agent. Oh, love this. The handler function that parses these tools emits events of any changes to the underlying network state caused by a tool call, as well as keeping track of what an agent knows, having it run for that specific tool. So this allows us to have a deterministic understanding of what paths represent real solutions in the network. Nice. So for creating, next section is creating trajectories using synthetic data generation techniques. So the world simulation layer produces complete trajectories of agent tool calls, an initial prompt as a goal, followed by the inputs and outputs of every tool call on the way to successfully accomplishing the goal. This can be done to generate arbitrary amounts of diverse tool call sequences for arbitrary networks without ever leaving the CPU. Nice. Since they're doing everything deterministically and probabilistically, I mean, yeah, you don't really need an AI model running on a GPU. You can just do that on your freaking processor. So an accurate network simulation and a high fidelity tool calls and their responses resulting in a complete objective is a good start, but there's a few things we need to generate to make trajectories training quality. We can now proceed to augment this data set with a strong LLM such as Kimi K25 using synthetic data generation techniques. Okay, so what are they doing here for the synthetic reasoning? So for each step, we want the result of the last tool call to motivate the next tool call. Reasoning tokens within a think tag have emerged as a standard way for models to reflect on the output of a tool call before issuing the next one. Since we have the full trajectory that leads us to success or failure, as well as the manifest, we can generate a chain of thought that mirrors what we would expect to see from a real agent activity exploring a real environment. Most models now prefer using think tags and tokens at inference time, so it's best that for the further fine-tuning data to reflect that style. It also greatly increases the entropy of the dataset, which we found to be useful during training. Oh, neat. So to be precise about what's synthetic here, the trajectories come entirely from the world simulation. Okay, the reasoning traces are generated by a language model given the full trajectory context. So we're not distilling attack behavior from a frontier model. The domain knowledge lives in the simulation. The language model provides natural language scaffolding around it. And during our experiments, we found it was crucial that the model generating the reasoning trace had access to the entire trajectory. So without encouragement to reference prior tool call results, reasoning became fixated on an individual tool call. So models trained on that sort of synthetic reasoning were able to justify any tool call regardless of what happened on the last turn. Basically saying it went from it basically became kind of like blown out, right? It wasn't ever really using that information in its entirety. Yeah, let me read this again. Because I think this is a very important part here. So during our experiments, we found it was crucial that the model generating the reasoning trace had access to the entire trajectory. So without encouragement to reference prior tool call results, reasoning became fixated on individual tool calls. Models trained on that sort of synthetic reasoning were able to justify any tool call regardless of what happened on the last turn. Basically meaning that it could very easily go, instead of going down a logical path, take a complete hard left and go down some illogical path. So this led to loops of recon that never built on prior information, with reasoning that was plausible but ineffective. Models that used more grounded reasoning used more of the surrounding context and did not suffer from this problem. And if you think about it, that's kind of what I was trying to accomplish with Hackbot, right? So whenever we would send this information like, hey, what's the next step? We'd send the entire piece of information about the host and everything we did from it. All right, so what about failure recovery? Because this is huge. You're always going to hit roadblocks. You're going to hit a failure. You've got to be able to pivot. Failures and missteps are a normal part of operations and environment exploration and are absent in the initial tool call trajectories. So the ability to issue one or more poorly formatted or unnecessary tool calls and get back on track is an important function of a robust security agent. So we make sure to add examples of erroneous commands, failed exploits, and their errored responses to ensure the resulting dataset does not give up after a one fat-fingered command. I feel that because I have fattest of fingers. Hey guy, what's up, man? Oh, hey Ryder, what's up, dude? And no problem, man. Hang on one sec, guys. All right, I'm back. Had to blow my nose real quick. I love this though. So everything they're basically throwing in errors like, hey, what happens if you come up with a bad command? Which is important because the language models are not perfect. They do a pretty decent job, but they still make mistakes with commands, just like a person does. All right, so back to the article. These techniques resemble what Blaise has published about synthetic playgrounds. So it is deceptively difficult to get these techniques to work at scale and lead to a high quality data set. Many hours are spent inspecting the data sets, but once the recipe is functional, these techniques combined with domain knowledge stack to great effect. Nice. All right, so for the results, from 0 to domain admin on Game of Active Directory. All right, so for training, Worlds produced 10,023 trajectories across 49 host networks spanning 2 subnets, 872 unique users, 31 Active Directory groups, realistic OU structures, 2,100 unique host principals starting scenarios, 10 host types, domain controllers, certificate authorities, SQL servers, web servers, mail servers, file servers, CI servers, VPN endpoints, and workstations. 5 distinct attack strategies emerged: ADCS certificate abuse, Kerber roasting, AS rep roasting, ACL and permission abuse, and credential pivoting. Nice. All right, so how do they evaluate this? So model evaluation setup. All models were evaluated with a single tool, allowing direct calls to the command line in a Docker container. We found this one tool command line wrapper representation of the tool layer was the easiest to translate into an evaluation harness. While it would be more efficient to express the results of these tool calls through compact context and simpler tool calling APIs, it made for a robust test of our techniques. Each model was allowed 5 episodes of up to 100 tool calls. Scoring used a compromise score based on what an agent uncovered in a network beyond the starting credentials. Points are collected for users when passwords or NTLM hashes are displayed in tool outputs, and for hosts when the local administrator password or hash appeared. Higher privileged accounts are worth more than regular users. Domain controllers are worth more than servers. Nice. I love that. They've got ranked scoring going on. We employed a context management technique where when the context window filled up, useful information was compacted and appended to the initial prompt. Oh, very cool. So what was the initial performance? They tried Nematron Orchestrator 8B. I haven't seen this one. What is Nematron? Tool Orchestra. Evaluating intelligence via efficient model tool orchestration. Actually, I have heard of Nematron. This was from NVIDIA. This was released a while ago, wasn't it? This is like a well-seasoned model. It's not like something brand new. I wish they had information about when it was released, but I do remember Nematron coming out. I just kind of forgot the name. Once I saw NVIDIA, I knew it was. Don't lie, you were pooping. I was not pooping. I was not. Let's see. Anyway, so let's look at the initial model performance. They first tested Nematron Orchestrator 8B. And this was chosen as the initial model for testing because of the kinship we felt with the interesting synthetic environment techniques during its own training. So we evaluated it with the credentials HODO. No points were awarded for this, with the goal of achieving domain admin. Nematron scored 0, making no progress in solving Game of Active Directory. Without grounding in Active Directory pen testing techniques, the model had a very 2017 idea of pen testing. Run nmap, see SMB server, load Metasploit, and see if it's vulnerable to any modules, and call it a day. So when that failed, it would load a password list and spray the domain before giving up. Even with valid low privilege credentials, Nematron didn't know how to leverage AD relationships to gain more information about the network. So the knowledge simply wasn't available in the training data. RIP. Hey Ardento, what's up, man? Has anyone compared the security results of Nematron versus Opus 4.6 versus Sonnet 4.5? Not to my knowledge. I don't know if anybody's ever made that direct comparison. I will tell you that we were using Sonnet 3.5 for the initial tests of Hackbot and eventually had to move off it to Sonnet 4.5 because Sonnet 3.5 was not following the prompting instructions at all. Sonnet 4.5 did way better and was far superior at handling the tool calls, but that's also a big difference in training. Sonnet 3.5 was largely trained in the chat model style, where Sonnet 4.5 was largely trained in the agentic interaction tool calling style. All right, so what are the training results? So for each experiment, we trained a LoRa adapter on different versions of world trajectories and measured performance against Game of Active Directory. So when synthetic reasoning or failure recovery increased data size, we removed samples to keep token counts consistent across experiments. That's cool they used a LoRa for that. That's neat. Tool trajectories only. So the loss of tool call only data quickly cratered, converging within 1,000 samples, and the model learned to predict the connection between different tools early on in training. So when deployed with this LoRa, Nematron showed no performance improvement over the base evaluation. Compromise score, bupkis, 0, nil, zilch, nada. During inference, Nematron always outputs think tokens before it makes tool calls. Without the reasoning traces in the fine-tuning data, Nematron struggled to make use of the information, even if it was already stored somewhere in the LoRa adapter. What about this? So next section is achieving domain admin using tool trajectories with synthetic augmentation. So taking the same data set and layering in reasoning traces and failure recovery changed the results dramatically. So the loss curve for these runs converged more gradually and continued to trickle down after several thousand samples. So this is consistent with the model learning to predict tool usage and reasoning. So the resulting model regularly leveraged the HODO credentials to AS rep roast a higher privileged account hash. Cracking the hash, it enumerated sysvol, found higher privileged credentials, dumped LSAS with them, and ultimately achieved domain admin in the north domain of Game of Active Directory. So that's one of the 3 domains in Game of Active Directory, with only access to the command line on a Kali Docker image. Nice. So the jump from 0 to domain compromise on a real network from just a LoRa trained on synthetic data validates our core thesis. You don't need real infrastructure to generate training data that transfers to real networks. That's awesome. So Nematron Orchestrator, the world's tool LoRa, nothing, nothing. Synthetic augmented LoRa, bam! Score of 30. Went from 0, 0, 30. Awesome. So how will synthetic training data impact security? So Worlds is the first step towards truly scalable, high-quality training data for security. The goal of this research was to determine whether synthetic trajectories generated at low cost could yield measurable gains on real-world evaluations. And this result confirms it. The implication of Worlds extends beyond training a single model. So for model trainers in AI labs, generate supervised fine-tuning datasets at arbitrary scale of any network topology, attack path, or scenario without provisioning infrastructure or handling sensitive data. Data ships in standard chat template format, ready for fine-tuning. Let's see. For red teams in offensive security, train task-specific small models that run on-prem without exfiltrating sensitive context to an API, control the model, the environment, and the data. Nice. I do like that idea right there. Let's see. So for defenders and detection engineers, realistic attack trajectories aren't just useful for offense. The same data can power detection rule validation, purple team exercises, and trading data for defensive models that need to recognize varied attack patterns. I'll actually go a little bit further than this, and that I think deception engineering is going to be one of the next big things, because let's be real, people are going to start using AI and LLM systems to start trying to speed up and improve coverage whenever they're doing offensive security assessments. And if you were to go let that LLM go carte blanche and just start running anything, it only is going to take one tiny little tripwire to run that, right? So for example, say you had an account in there that looked really juicy. Yeah, you could AS rep roast it. Anytime that sucker gets AS rep roasted, bam, instant tripwire. You get an alert for it. Or you have a really juicy curb roast target, right? That curb roast target goes in there. Anytime a TGS is generated for it, boom, instant red flag, all the alarm bells sound. Or you just have an open network share on the environment, and anytime something touches it, bam. There's so many places in there that you could basically put claymores in your network. Let's see. They also had suggestions for security product teams. Build domain-specific security capabilities into your product without needing access to real customer networks. Let Worlds generate the distribution for your model, for what your model needs to see. With the working recipe in hand, we're already running the next round of experiments. Larger models, more diverse network configurations, and longer training runs. So at the release of Worlds in the next few weeks, customers will be able to generate SFT datasets for their own models on demand, configurable network sizes, topologies, attack strategies, and output formats. So in conclusion, we took an 8 billion parameter model from zero to domain admin using synthetic data alone. That's awesome. That is so cool. Here, I'm going to drop the link for this if y'all want to go check this out. But I freaking love that. It's great. Hold on, Hats. So it's very interesting research and preliminary product for music studios to post-process songs in a way that they still sound from a human, but AI recognizes a completely different style. Well, if used to teach generative AI, it'll produce a cacophony. Oh yeah, dude, there's already lots of different ways to basically make something look legit, but it's complete poison to a language model system. That's awesome. I love it. All right. Let's go back over to Bad Sector Labs. Let's see what we got in here. Iran is bringing their internet back up. Let's see. Red Macros Factory was joining Outflank security tools. Let's see. By the way, if y'all didn't see this, I know it's been all over the news, but Microsoft gave FBI keys to unlock encrypted data because BitLocker keys, if you have a Microsoft account and you're logged in on Windows 11, get backed up to your Microsoft account. So, yay. Good job, Microsoft. Well, there's a guy who makes YouTube videos with microphone beamforming. Hadn't seen that. But oh, it's his company that does it? Interesting. Well, let's see. Automated game of active directory and live malware labs. Looks cool. What is this? Someone knows Bash far too well, and we love it. Ivanti pre-auth RCEs. Any Bash script greater than 50 lines should be written in something else. That's a quote from the author here. Every time I write a long Bash script, the POC request appeared in a dream. And it's not your honeypot, sure. Hold on, I gotta read this just with the title. Let's go look at this. Oh, it's from Watchtower. I love these guys. They make the best vlogs. The snark is just so delicious. It has to be fattening. Hang on, before we dive into this one real quick, I need to go take care of something real quick. I'll be right back. All right, I'm back. Oh, it was the guy who did the storing data on birds. Oh, okay. And no, Gumby, I was not pooping. I was refilling my water because I was out. What happened to the... All right, there we go. Guess that's a good scroll. Let's see. Good old Avanti. All right, so this one is article from Bad Sector. No, not Bad Sector Lives. This is from Watchtower. Love these guys. Ivanti Endpoint Manager Mobile exploits here. Someone knows Bash far too well, and we love it. Pre-auth remote code execution. So when Ivanti removed the embargoes from CVE 2026-1281 and 1340, actively exploited pre-auth remote code execution vulnerabilities on Ivanti's Endpoint Manager Mobile solution, we sighed with relief. Clearly, the universe had decided to continue mocking security by design signers right on schedule every January. Love that meme. So welcome back to another monologue that doubles as some sort of industry-wide counseling session we must get through together. So as we're always keen to remind everyone, today's blog post didn't ruin your weekend. The APT currently exploiting these vulnerabilities and your lack of response to the warnings from Ivanti and CISA did. All right, so what is the EPMM? So Ivanti's Endpoint Manager Mobile enterprise mobility management platform used to manage, secure, and enforce policies on mobile devices, apps, and content across iOS, Android, and other endpoints. So it's commonly deployed by large organizations to control corporate mobile fleets, distribute apps, and protect access to enterprise resources. Protect. Let's see. So move on, Watchtower. What's going on today? In this week's episode of Advisories Issued by Ivanti, we see two vulnerabilities here that have been detailed. So one is a 9.8. Code injection in Avanti's EPMM allows attackers to achieve unauthenticated remote code execution. And another one, code injection in EPMM allows attackers to achieve unauthenticated remote code execution. So as always, the following line in the advisory sticks out like a sore thumb. We are aware of very limited numbers of customers whose solutions has been exploited at the time of disclosure. Quote, we are aware, and quote, very limited, are likely, in our opinion, this is probably not fact, to be doing a significant amount of lifting. So for avoidance of doubt, the following version of Avanti EPMM are patched. None. But Watchtower, what do you mean? Well, Avanti are issuing patches with commitment issues. You have to reapply after any subsequent changes in the future, or they of course get rolled back. So until Q1 of 2026 when they released the version 12.8.0.0. And their notice said, we strongly encourage all EPMM customers to adopt version 12.8.0.0 once it has been released later in Q1 2026. Once you've upgraded 12.8.0.0, you will not need to reapply for the RPM script. We are providing technical analysis that includes affected endpoints specific and log analysis guidance, which you can find here. Customers should determine their own risk appetite when securing their environment. The most conservative approach, regardless of exploitation, would be to build a replacement EPMM and then migrate data to that device. So their guidance is assume you got pwned, make a new one, migrate your data. Yikes. So these temporary patches with commitment issues, RPMs are, as of the writing, called this one and this one. I'm not going to read those out. To signal even more severity, it's clear that this is bad as they got insta added to CISA's KEV list. So without further ado, let's dig in. Let's see, as we mentioned, Avanti delivered RPM patches to customers under embargo and are still paywalled to help implement mitigations. I don't know, does anybody know about what Avanti's patching situation is? Because this is completely foreign to me. They delivered RPM patches to customers under embargo. I mean, do they mean that they're under export embargo, where they can't send those to customers that are in certain countries? Is that what they mean? So for the purposes of this analysis, we're focusing on RPM patches related to the 12.7.0.0 version. RPM doubles as an ultra hacking tool, allowing us to see what files are stored within that package. Ultra hacking tool. So we can see that it stores two uncompiled JavaScript files. So far, so good. But what actually happens to those files? We can see. We can again use RPM to list the contents that will be executed during the installation. So for this purpose, we're going to use an RPM command with a script to go pull those packages out. If we go through the important steps one by one, the most important fragment of the scripts are as follows. So they run the Java compiler against the App Store URL mapper and ATF URL mapper. And we can see that the Java classes are being compiled, quite logical. Afterwards, we are seeing some basic file system operations, which is applying patches, modding them, owning them, copying them, basic stuff. Compiled classes are moved to the mebin directory and prepared for execution. Boring stuff aside, we've reached an actually interesting part. Suddenly, the script started modifying the Apache HTTP dconfig. So they drop some Java, but then they start modifying their Apache configs. So they're using sed. They're looking for this rewrite rule here. So it goes map app store URL, and they're rewriting it to So did they have an executable in there? Now they're actually saying, hey, we're going to actually map this over to directly call Java. See that? So before it was calling this program directly. And now the program is actually going to be Java executing in this directory, this class right here. So it has two Apache rewrite instances defined, which point to shell scripts. Oh, okay, so those were shell scripts in there. After the patch, the aforementioned bash scripts are no longer used. The patch modifies the rewrite map instructions, which now leverage the newly introduced Java classes, entirely replacing those bash scripts. This pretty clearly indicates one thing: the vulnerability must exist somewhere in those bash scripts, or Avanti's new approach to vulnerability is to refactor everything, which honestly doesn't strike us as the worst idea. So reaching the bash scripts through HTTP, and Avanti is an HTTP-based enterprise solution, and it appears that RPM patches provide amended items within the Apache config, and we can logically conclude that the vulnerability must be exploitable over HTTP. Makes sense? So as the mappings are in the Apache config, we can have another look to see what they were used or where they were used. Taking the path of least resistance to everything in life, we leveraged another hacking tool, grep. Good old grep. So we just grepped through the config looking for the map app store URL for the mapped occurrences, and multiple results popped up. Hey man, what's up, dude? One of them came up as followed. So this rewrite rule here, looking for some kind of SHA-256. And then it uses this. Okay. So what's happening here? Okay, good. I'm glad they're going to break it down because this is kind of dense and I don't feel like going through all the steps of it. So if you send an HTTP request targeting the following endpoint, which is this App Store fob something, there's an integer, a static string of SHA-256 something/something.ipa. And Apache is going to execute the App Store URL bash script with that input. So something1, integer something2, host header, endpoint path. All right, cool. Oh, okay. Got you, Gumby. How are you finding those bots? Because you've gotten really good at it. All right, so knowing what the path is, how to trigger it, and kind of what's being passed to it, we have everything an attacker may dream of: an unauthenticated endpoint, and the ability to pass attacker-controlled strings to the bash script. Oh, it linked to that same webpage? Gotcha. So let's do this. Okay, so coming back here. So we have two key things here that's happening. That HTTP call has no authentication requirement, and you have attacker-controlled bash strings that you can pass to bash. Nice. So a simple experiment using the following request, where they send in all sorts of yummy data. And with a little bit of tracing and debugging, we can follow the request to the inputs passed to the map app store URL bash script. Oh, that's long. That's what she said. So as you can see, we're controlling seemingly a lot of things. So time to bleed our eyes with bash then. I love the section titles they have here. The one where we lose all of our hair. So at that point, we were blissful and optimistic. Everything, literally everything, looked like a straight way to the RCE. We mean, how hard can it be? Surely we just inject some OS commands with some fancy mashed characters. Haha, how naive we were. So we're looking at both bash scripts for several hours, only to say that we saw absolutely no way to exploit them. So let's start with the basics. The bash script allows users with all the correct ingredients to retrieve mobile applications from the Avanti EPPM approved application store. So to achieve that, you need to provide the KID, which is an index salt string, the ST, which is the start time, ET, which is the end time, and H, which is a SHA-256 hash based on several inputs, which verify whether you know the secret salt or not. The App Store file to retrieve in our request was this salt right here. Was it this 1FC07? So assuming that the H hash in our script is correct, the HTTP response will contain the contents of whatever that file is. So nothing fancy, just a script which retrieves a file, verifies whether you know the proper file name, which is GUID, and the salt, which is stored on the local file system. So there's no point in boring you with the script content so far. However, you need to know that we spent a significant amount of time exploring any and all potential command and code injection points in this bash script, and we found nothing. We found some minor argument injection issues, but meh. All right, so the final exploit was an arithmetic expansion? No. What? So call it divine intervention or whatever you wish, but we went for a nap, And the proof of concept request appeared in a dream. And it looks like this. So what did they do? So they set the KID to 1, ST value to something. The end time. Oh, that was the start time right here. Boop, right here. And H was path, sleep. Wait, what? So then it sleeps for 5 seconds. This %20 here is a space. Okay, so let's decode. Okay, I gotta know because I don't remember what all the percent modifiers are offhand. So we URL decode this. You haven't stared at URL encoded values for years. You can automatically decode it. So it goes to G path sleep 5. There. So fairly bizarre, right? So, well, first of all, there's some references in passing of the key equals value values in that App Store bash script. So the key map entry comes in here. So they pull out the key, the value, and they log the debug, which is a function name. Let me see. So the inject happens, hold on. So the inject happens in the H value here. The value. Hold on, what are we doing here? I don't get where they're going with this. Oh, hang on one sec, guys. All right, I'm back. I didn't know where Sock was. Oh, no, I knew where Sock was. I didn't know where Peaches was. And I knew she wasn't far. I knew she wasn't outside. Sock just came to tell me she's sleeping in the dirty clothes in the laundry room. I thought it was weird she wasn't hanging out under the desk like she normally does. No, apparently she just wants to go sleep in all the stinky clothes in the laundry room. Freaking weirdo little dog. How do you even read bash? I mean, I've written the code for my own CPU core, and I was too lazy to write assembly for it, but bash and regex, I do not comprehend how a human can read it. Yeah, bash has a lot of intricate parts to it. I was not tending to a tied-up person in the basement hats. Fun fact, you rarely see basements in Texas because of the soil structure, which is unfortunate because I would love to have a little basement command center. I find it sad that we don't get basements in Texas. Anyway, so let's break down where we're looking at with this. Hang on. So I gotta zoom out a little bit because they're looking at code section 1. Here we go. So they get the start timeout. Where the heck is the value? I don't know what the value is. Like I said, Bash has some really weird intricacies. But anyway, so at 1 and 2, you can see that ST and H values are assigned inside of a case. Okay, so let me look at this case real quick. So here's 1. Oh, right there. There's the ST value. Got it. Okay. Oh, freaking case logic in Bash is abysmal. So what they're saying is they're looking at the key value, right? If it's kid, it does this. If it's ST, it does this. If it's the H value, it does this. So what they're doing is they're doing ghash prefix string equals whatever the value of that is. Okay. So the ST and H values are assigned inside the case, and you can see a familiar reference with the value. Note the ST value of the HTTP request. However, what about the G path that you can see the H argument? Well, that's just a variable that had already been defined in the bash script, so gpath was nothing. So ghash prefix string. All right. The absolute magic happens when the current time in seconds is minus than the greater than the start time. I didn't even see that. Hold on. Wait, was this in here? Oh, okay. I guess it wasn't in the code snippet. All right. So apparently there's an arithmetic operation here that happens that says get the current time and check and see if it's greater than the start time. So this is a completely harmless line, right? It only compares 2 timestamps. But wait, what have we defined for the G start time ST in the HTTP request? The value. So the parameter contains 2 additional padding spaces at the end to ensure the string is 10 characters due to string length validation checks. So the G start time points to the value variable. So you may remember that the value variable was used to extract our key value pair during the for loop of the case statement. What is the last value that we extracted that's been assigned to the value? gpath sleep 5. So during the arithmetic expansion, so what's happening is here, it's taking this and it's taking these values here and then doing an arithmetic operation on it, expanding the variables out here. Current time, G start time. And so up here, if we look at this, so the H value, we pass in gpath right here. So that goes into H, which is the ghash prefix string. And we already have gpath in there. Trying to make sure I'm walking through this correctly. So we already have something assigned from the value, which is this gpath here. So during arithmetic expansion, if a variable is treated as an array and the array index contains a command substitution, the shell will execute the command while resolving the index. So those backticks there is a command substitution saying basically gpath should be an array like this. However, this is a command, so it should take the output from that and basically make that an array in here. That's funny. So in this case, the gpath variable is used, although any defined variable names would behave the same way. So when the expression is expanded, the sleep5 command is executed as a part of the process. Eval input? Nah. Eval this? Bay.
Caution. A virus has been detected.
The Shy Hat virus detected in the network.
The Shy Hat virus. What's up, everybody? Getting down with the hip-hop hack? The hip-hop hack? Welcome in. We're doing our usual hacker news. Let me see here. Shit. No. Let me make sure to get you a shout out real quick. Here we go. Oh wait, I think Gumby already beat me to it. Nice. What's up, guys? Welcome in, Raiders. Shahat, what were you working on? Hope you're having a good time tonight. Happy Wednesday, everybody, by the way, in case I didn't say it. Apologies for starting the stream a little bit late. I was dead to the world and I slept through the stream start alarm. And when I say slept through it, I mean in my completely incoherent state, I managed to turn the alarm off and go back to sleep. So I woke up a little late. So, guys, what we're looking at here, by the way, if everybody just came in on the raid, is there was an remote code execution, unauthenticated, on Ivanti's basically endpoint management system. And we're going through and reading through how this was actually set up. And the long story short is, Ivanti made some poor design choices that looked good on the surface. However, somebody with a deep knowledge of Bash proved them wrong. Oh, we're working on how to get Groovy script to execute in a Jenkins app. Oh, nice, dude. No, dude, that's awesome stuff. It's awesome. Especially anything that revolves around compromising CI/CDs. Those are some of my favorites. In order of importance, if I get into a company and I can compromise their CI/CD, that's big. If I can compromise a dev environment, that's big. If I can compromise a security environment, that's big. Those are like my 3 juiciest targets. When I see them, ooh, just want to go right after them. There's so many secrets stored in CI/CDs and so many ways to steal them out of it. I love it. Yes, security tools are my other favorite because a lot of security teams will go set their stuff up and not necessarily follow best practices themselves. So not always the best security, but lots of security authentication or authorization. Yes. It's beautiful. It's beautiful. So the long story short here, so to catch y'all up, there was an unauthenticated endpoint in here where an attacker could pass something that doesn't look crazy. However, the way the bash script was structured, they actually could go inject a command substitution in here, but it wasn't readily apparent whenever it came through. So that's what we're kind of just reading through right now. They had this weird time comparison to make sure that a current time and whatever this operation start time matched up, but you could actually inject a command execution in the start time. It's kind of funny. All right, Shahhat, take care. Good to see you again. Let's see. So what happened here was because of this arithmetic expression, the greater than, this expansion for these arrays in here, command substitutions to build this GPath array, right, is going to fire first before the execution happens. And so for additional details on the magic of arithmetic expansion, see this blog post and this Stack Exchange thread. In short, the bash script uses one variable, which is gStartTime, to reference another variable, which was the value, where a command, which was just sleep for 5 seconds in this example, is executed as a result of the arithmetic expansion and the shell evaluation. Nice. Excellent. That's so cool. Here, I'll drop this in the chat for anybody who wants to go take a look at it. And potentially, if you're running Ivanti in your network, you want to go take a look at that. So to prove our analysis and give you the beginnings of creating your own DAG, we represent the following request, which executes ID and sends it into MIPAC for the OS command. So here in, right here, so GPath, ID space, redirect output to me POC. That's funny. And if we go look at that, we see that if we look at that file, right? Proof of concept, of course, this was running as root. Of course it was. Oh, that's funny. Too good. I love the guys at Watchtower because they have the snarkiest exploit analysis blogs. They're so great. Let's see. I think this was actually, you know, I was talking about this blog earlier. This is the one I was talking about. Yeah, Sean Heelan's blog. I'm not going to go over it now because we actually went over it last week, but I'll drop a link to it since I was talking about it. Yeah, mind, they have the best memes in their blog post. So, but this was the blog post I was trying to remember on the coming industrialization of exploit generations using language models. And this one was a pretty cool one in here. It fit in nicely with the research from Anthropic's Red Team about what they were doing with Opus 4.6. Let's see. Void Link, we already covered that one. Oh, this one. Yes, hold on. I do need to read through this one. Because I used this before it was put into Mythic. Hold on. I need to delete out the header real quick. Oh, man, every time I pull up the dev tools on the SpectreOps site, it just completely hoses up. I think it's this one. I don't know what it is. I need to tell them, hey, I need y'all to go redo your stuff here. Can I close it? Hold on. Let me reopen that real quick. All right, let me see if I can get this maybe down here somewhere. I don't know why the site always does this, All I'm trying to do is delete out the header banner because it takes up a good chunk of the screen whenever I'm zoomed in all this time to make it more legible for the stream, right? Come on, do stuff. Come on, delete. Also, Anton, thanks for coming online, man. Why you do this to me? Why you do this? I need to tell them about this. Wait. Refresh. Oh my gosh, what is going on here? All right, we'll just have to suck it up with the banner because I can't even get... For some reason, Chrome is choking on itself with this. What is Bloodhound? Bloodhound, yes, you're technically correct, Mind. Bloodhound is a dog. But Bloodhound is an attack path mapping tool for Active Directory. But that was the initial implementation of it. And then it evolved from that using graph databases and Neo4j to encompass a lot of other things. So a lot of stuff you find in the Microsoft ecosystem. So it covers Active Directory, it covers Azure, or technically Entra, I guess maybe both. But recently, the guys on the Bloodhound team at SpectreOps, they released something called Open Graph that allows you to go through and define your own nodes and edges. So that way you can say, okay, cool, this is how it kind of flows through here. Let me try something real quick. I'm going to zoom this out back to 100%. Okay, there we go. Leet Hacker Mans, deleting stuff off the DOM. All right, so the reason why I'm very interested in this one is because I know Alan, he is a fantastic guy, and this is Weaponizing Whitelist, an Azure Blob Storage Mythic C2 profile. So essentially what this was doing, and I've done this before on a red team assessment, but we were doing it through Loki C2, and I like the idea of Loki C2. It is just a beatdown to use. So this being brought over into Mythic highly interests me. And the idea here is, let me break this down real quick. Sorry for the flashbang. Boop. Fixed flashbang. All right. So what's happening here is, let's say you have landed a C2 payload on some target machine, right? You always have the problem of you've eventually got to talk back to your server. In this case, I'm just going to call the server Mythic. We're going to assume we're running it, right? And so this channel here looks nice and straightforward. But in reality, you've got a lot of hops you've got to go through. You're going to have some switches in here. You're going to have some routers. You're going to have the internet here. You're probably going to have some kind of a firewall going on in here, right? Firewall. And then eventually, after the data takes all these hops, then you might get back over to your Mythic server. So this right here is kind of like the idealized path. Like, oh yeah, cool, you just come straight out to it. In reality, it gets far more messy, and there's things in there that want to mess you up. So what does everybody trust? Everyone trusts Azure, right? Because Microsoft has their hands in everyone's pocket. So under Azure, what you have is you have this raw storage capability called blobs. So here in blob storage, this right here, firewall sees this guy and goes, no siree Bobski, you can't talk to that guy. Oh, you want to come over here and talk to blob storage? That's totally fine. So what we do is we just build blob storage as a C2 path. So we write instructions to it. Those go up to the C2 agent, and then its responses get written back to blob storage. So you're using this as a C2 infrastructure. This guy right here, firewalls see this, they say, yeah, Bubsky, that's totally fine. In fact, it's Microsoft's best practices to just go ahead and whitelist all this crap over here. So, yeah. Oh, hey, Chris, what's up, man? It's basically blob storage can be not just raw storage. It's also like file defined object storage. It is essentially what Azure's version of S3 buckets is. So hey Deefus, have you talked about the Blood Dash tool mentioned in Last Week in Security yet? Oh, I didn't see that. Hang on. Because I haven't gone through all of Last Week in Security. Bloodhound alternative, Blood Dash will ingest the same files as Bloodhound, but no server is required to use this tool. It's great for quick AD enumeration. Oh, okay. Yeah, we'll take a look at it here in just a second. Anyway, so back to this. So what this article is talking about is how it's going to do that. So the TLD, what was the article called? Weaponizing Whitelists, an Azure Blob Storage Mythic C2 profile. So the TLDR is mature enterprises lock down egress, but often carve out broad exceptions for trusted cloud services. This post will show how reviewing deployment guides can help identify those exceptions and weaponize them with a new Mythic C2 profile called Azure Blob. Hosting C2 redirectors? Nah. Azure Blob Storage. Yeah. So during a recent hackathon, we discussed some common issues operators run into. One unfortunately common one is, in very mature enterprise environments, highly restrictive egress firewall rules or network proxy rules would prevent operators from receiving callbacks to their targets. As a result of these roadblocks, we reviewed installation and deployment guides and discovered that many vendors will recommend broad wildcard exceptions in firewalls and proxies to ensure cloud services function during initial deployment. So for example, guidance from Citrix for system connectivity requirements parallels remote application servers with Azure Virtual Desktop, or Nerdio Enterprise Manager all include rules allowing outbound access to Blob Core Windows Net in some fashion, and all the various subdomains. So that insight led us to build a new Mythic command and control profile, Azure Blob, that leverages Azure Blob Storage and integrates it into a modified version of Medusa as a proof of concept. Azure Blob Storage is Microsoft's object storage solution for the cloud and optimized for storing massive amounts of unstructured data. Oh, I think I lost it. Where was I? There we are. So using Azure Blob Storage isn't a new method for C2 comms. Tools like Loki already demonstrated this, but we wanted to develop a proof of concept that could extend into other Mythic agents and have SOC support. So we took some additional OPSEC precautions around the Azure container and token scoping detailed in the container isolation and token security section. Next, we'll dive into how to set up and install the Mythic C2 profile, Azure Blob, and discuss how it works. Awesome. So the profile setup looks pretty straightforward. So before we dive into the configuration, we need to perform some setup in Azure first. So we got to go create the blob storage. So you log into Azure, you go to storage accounts, you create one, you make it you assign it to a resource group, a region, select premium performance, only the best performance. Look at block blobs. So actually, this case, Chris, it would be more like what you were talking about. It's raw storage. It's block level storage instead of like file level storage. Oh, you finally got your Linux working? Nice. Hey, no problem, Chris. Let's see. Other steps you're going to perform is local redundant storage and then review and create it. Boom, you spin this up. And you know what sucks is the time I was doing this, when I was using Loki, was right when that massive Azure outage happened. It was at the end of last year. And so I had to go contend with this BS trying to get the blob storage stood up. It took over an hour to deploy a very basic blob storage. Way to go, Azure. Way to go, Microslop. So next, you'll need to retrieve the storage account key under security and network and access keys. So you get your access key here, and then install the C2 profile for your Mythic server. So you have to install 2 of these because you got to have the C2 profile. That's a different plugin, basically. And then looks like King of the Nops, who is Andrew Gomez, made the Medusa fork so they could incorporate this. So with the C2 profile and agent installed, the next step involves configuring the C2 profile. So you go through, you configure it, edit the configuration, put in your key, boop, and you're good. So then you go through and create your Medusa payload, set it up, go through your build parameters. And so for demonstration purposes, we disabled HTTPS verification, payload obfuscation, and set the AES pre-shared key and encryption exchange to false, because I want to be able to see it in clear text when it's on the block storage. During an actual engagement, we recommend doing those. That's true. But anyway, they go through and they build the payload. So here's how the conversation is going to work. So the Medusa agent will have the build initiated. It's going to request container creation in the blob storage. It's going to go make that. This is going to return all the tokens, the container name, and the blob endpoint, which is a URL of where you need to talk to it. It's going to update that base agent payload and then release it for download. So every agent that gets built, it's going to have its own basically set of block storage that it's going to use up in Azure. Boop, boop, just like this. Nice. In the back end, when this payload generates, the builder Py script with the Medusa project executes, and we modified the script to check which profile the operator selected. If the operator selected Azure Blob, an RPC call sends the C2 profile generated to the blob storage container scoped to that specific payload with an agent prefix, basically as the container name. And once the container is created, the container's name, the SAS token, blob endpoint, all the goodies are sent back so it can finish embedding them into the payload. So there was another part here, server-side infrastructure provisioning. So one design goal involved eliminating any unnecessary traffic from agents to Azure Management APIs. So all Azure infrastructure provisioning happened on the Mythic server during payload generation. Agents never make calls to Azure Management APIs. They only put, get, or delete blobs in their assigned container. So the C2 profile exposes a custom RPC function for generate config. That payload type then is called during the build process. So it generates everything and embeds it, basically. So when you build the payload through the Mythic UI, what happens is your payload type gets embedded, and if it's successful, boom, there's all the information that it gets. Well, actually, it goes through and it generates all this, and then it embeds it. So the RPC function reads the storage account credentials from the server's config JSON, creates that container, generates and then keep in mind, this is not like a Docker container. This is a storage container on Azure's Blob. Once it's done, it creates that scoped SAS token, returns everything the agent needs, and the agent never touches the management APIs. Nice. This approach means the C2 server can discover new agents automatically by listing the containers with the agent prefix without requiring agents to register themselves. Very cool. So for container isolation and the token security, the storage account key never leaves the Mythic server. Agents get their own container and only receive a container scoped SAS token, SAS, that restricts access to their assigned container. And this is very important because what happens, let's say you're on a red team engagement, or you're just on any other type of, well, I won't say any other type of engagement. Let's say you're on a red team engagement and the incident response team doesn't know, it's an unannounced red team. They're going through and they're working through this. And let's say they're able to reverse engineer this and find out where that container is. If this wasn't scoped appropriately to their container, they could, in theory, go and start reading all the other information that's in that blob storage, right? So what does that do? Instantly gives away any other payloads you might have running in that environment, any other implants. So this is deliberate departure from how other Azure C2 implementations work. Existing implementations typically bake an account-wide SAS token into every agent, meaning a burned or reverse engineered agent exposes those credentials. And that can access the other agents, list all containers and storage accounts, read keys, delete data across the entire operation, or even issue rogue tasks to agents that obtain the AES encryption key. So imagine that. That would be a nightmare scenario. Because imagine maybe one of your payloads accidentally gets sent over to VirusTotal. Some nerd picks it up. If you didn't know that, everything submitted to VirusTotal can be downloaded and reverse engineered. And then somebody does that. And then now they've got access to your entire C2 framework right there. Boom. Not to Mythic, but to this, they basically have access to your C2 comms and can go read all that data. Assuming you didn't put in encryption, which you should have. So with these container scoped tokens, a compromised agent can only access their own container. The blast radius is limited to that single agent. And the SAS token expiration ties with the payload kill date selected during the generation whenever you build it Mythic. So the tokens automatically expire when the payload does. With an understanding of how the server-side provisioning works, we're going to break down the C2 communications. So for here, we have Mythic polling and retrieving responses. That's going to, actually, let's start with Medusa over here. So Medusa agent gets executed, it checks in. It writes this blob storage over here. It polls and retrieves the responses, forwards that blob to Mythic to send a Mythic response. Boom, boom. This one polls and retrieves the response, deletes the blob, processes the task and the requirements, creates a new blob, and then basically this one comes in, polls and retrieves it. Boom, boom, boom. Just like that. Okay, yeah, I could make that work. Cool. All right, sorry, I had a message up on Discord. One of the guys was asking if I could pin the articles as we're going through them. And I think I can. I think I can do that fairly simply. In fact, here, we'll go ahead and do this real quick. Let me see here. Pin. Boop. There we go. Excellent. We can start doing that right now. Let's see. All right, so we already talked about kind of what the, back here at the article, what the flow looks like, right? So checks in, creates a blob, Mythic reads that, updates the blob, and then I believe it comes through, deletes the blob? Actually, let's see what his explanation is. So the message flow follows Mythic standard post message and retrieve response and get message and retrieve response patterns, making integration to other agents pretty straightforward. So to send a message, agent generates a unique message ID, agent uploads an encrypted message to that blob via put, agent polls for the responses, agent deletes the response blob after reading. Oh, okay, so it reads it in, nukes it off, and then it's good. All right. C2 server runs polling in the loop. List all the containers with the agent prefix. Each container lists blobs in the ATS folder. Download and delete each agent message. Forward to Mythic. Write Mythic responses to the corresponding blob. Nice. So each message includes a UUID prefix followed by JSON matching the Mythic expected format, which is pretty much, that's how Mythic does everything. UUID and then JSON. Hey, Klondike, what's up, man? Let's see. All right, so for the Pegasus test agent. So the Azure Blob repository includes Pegasus, which is a minimal Python agent with two main purposes. One, validate your C2 configuration or try out the profile without having to do any agent dev. And two, reference implementation with simple stripped down code that can serve as a template for integrating C2 profile support to other agents. So the agent code contains placeholders that that Mythic will replace during payload generation. When the payload builds, the agent's builder pie calls the C2 profile for generating a config. That RPC function then provisions the container to get the SAS token, then stamps those values into the agent code. The account key is never stamped, only the scoped SAS token. So let's say it limits the blast radius to that one container. If that agent gets burned, just that one container gets burned, not all of them. Let's see. So Pegasus supports a shell, whoami, present working directory, hostname, and exit commands. Demonstrates the full message lifecycle. Additionally, the test agent does not support crypto, so we don't recommend operational use. We built the agent for lab and personal testing. Let's see. So you can build a Pegasus payload through the Mythic UI. If it checks in, your configuration is correct, and you can proceed with integrating that profile into your actual agents. So we designed the profile to work with any Mythic agent you need. So in your builder pie, you can call generate config RPC function during the build to provision the container and return a scoped SAS token and replace a placeholder variable. In your agent code, you define the placeholder variable to be replaced and implement the blob's put, get, delete operations against the ATS and STA. Oh, I guess that's agent to server and server to agent. I didn't realize what those were. That's funny. The agent comms to the Azure storage are pretty simple. They're HTTP REST API calls. made using standard request libraries available in most programming languages. You may notice that we've used the Microsoft Azure Storage Blobs Python library for the server-side container provisioning and account-level administration that's necessary for the C2 profile, but not the agent. And while storage client libraries and SDKs exist for many languages, they're not necessarily for the simple read-write-delete operations that the agent requires. So we can choose to build our own simple requests with standard libraries in order to avoid the payload dependencies, providing us extra customization options. Future work. So while testing socks with Medusa and the Azure Blob profile, we saw speeds of around 19 to 21 kilobytes per second. Not the speediest, and it makes sense because that's a big loop to go through. So these speeds were by no means pleasant, but Andrew Luke and Paul Kim spearheaded an effort to port the client side of Proxy Blob from Go to Python for inclusion in agents that support Azure Blob Storage C2 profiles. Proxy Blob is Quark Labs' purpose-built SOCKS 5 proxy designed specifically for Azure Blob Storage support, achieving speeds of around 1.5 megabytes per second. Pretty decent for a SOCKS 5 proxy. These speeds would provide a huge improvement over our tested 21 kilobytes and bring the target SOCKS capabilities via Azure Blob Storage to a level that robustly supports proxying in offensive tools, which I'm a big fan of. That's one of my favorite ways to handle not getting caught when I'm doing a red team is just proxying your tools. Don't proxy into Impacket though. Impacket has a lot of telltales. That'll get you caught. Let's see. So in conclusion, deployment guides are a goldmine for information for defenders and adversaries. Oftentimes, these guides leave opportunities to develop techniques that live inside what organizations already trust. Azure Blob Storage isn't a new method for C2 comms, as popular tools such as Loki already demonstrated this. We just wanted to expand the groundwork already laid. We designed this Mythic profile to help others integrate Azure Blob Storage into their Mythic C2 agent. Huge thanks to Cody Thomas and the developer series, everything, yada yada. Also, shout out to Andrew Luke and Paul Kim for their help. Shut up, baby, I know it. Thought I forgot, didn't you, killer? Awesome, I love this. All right, hold on. So this will be the last thing. We'll wrap it up here for tonight. But one of the guys in chat had mentioned Blood Bash. So let's go take a look at this. From somebody, Squidsec? I'm not familiar with them. Blood Bash. I love that. Blood Bash. Get it? You get it? Let's see. So this is a standalone Bloodhound JSON analyzer written in Python. Parses Sharphound JSON files without Neo4j or the Bloodhound GUI. Builds a directed graph using Network X. Nice. Correctly identifies object types, finds attack paths, detects vulnerabilities, especially ADCS escalations, and provides Bloodhound-style queries with rich colored output. Perfect for red teamers, OSCP and CRTP prep, and fast AD reconnaissance when you only have the raw Sharphound data. I mean, it's not really that hard to go spin up a Bloodhound container, but it's always nice to have options. Let's see. Offline and air-gapped? The hell it's not. You spin it up and then you talk to it. You can have it offline and air-gapped. Anyway, I'm gonna dispute this claim. I get where they're going with it, but you're running a Docker container. You can just do this. All right, there we go. This is pinned now. What else we got? Speed for quick scans. Slow, ingest, GUI load. It's not that slow. Bloodhound CE is not that slow. I don't doubt that this is probably faster, but Bloodhound CE is not that slow. Resource usage? Oh, this probably wins like hands down because there's a lot of overhead for Neo4j. So yeah, I'm going to say Blood Bash wins like hands down for that. Output interactive graph. Not necessarily. Depends on what you're outputting. I would like to see what it's exporting, though, because I bet you probably could get some fairly clean exports if you know what you're doing. I'd say Blood Bash may not be the best if you are learning about like managing attack style graphs in Active Directory, but I think I want to see if you got some examples of the output. Let's see. Best for deep exploration, blood bash, rapid recon, field work, scripting. Okay. I like this. I like this. Let's see. Install is fairly simple. You git clone it, you make a virtual environment, you run it, you're good. Let's see. Looks like it's got some built-in predefined paths in here. It looks like, is this a TUI or a CLI? Looks like it's a full TUI. So if no flags are specified, the script runs use all for full analysis. Interesting. I mean, it looks pretty cool. Like I said, I'm always in favor. I'm not going to come in and bash this by any means. I'm always in favor of having another tool in my tool belt. There could be times when, hey, I just, Docker has taken a crap on my laptop and I can't use it. So this would be a decent fallback, right? A really decent fallback. I like the idea of it. Now includes Metasploit module. What? Oh, cool. He wrapped it into Metasploit. That is pretty cool. I always still have I know I joke about like, oh, Elite Hacksaw using Metasploit. I still have a soft spot for Metasploit. It was one of the very first, like, hacker tools that I really dug deep into. I still love Metasploit. Example output. Let me see if I can... Now, the zooming doesn't change this here. Oh, wait. I can scroll to the side, though. Let me see. So it's doing RBCD checks, curb roastable accounts. Does an abuse suggestion? Ooh, I wonder how he's doing that. Nice. And it completed that in like 0.8, not 0.8 seconds, 0.08 seconds. That's crazy fast. Nice. I gusta. I like it. I think that's pretty cool. Star that. I'm going to put that under red team. Anything else in here? No, I'm not going to put that in hacking labs. Let me see. Yeah, I'll stick that in red team right there. Maybe in Hackbot references, because eventually I was thinking about connecting Hackbot to Mythic, or not Mythic. There is a Bloodhound MCP server. Let me go see if I can find that real quick. Bloodhound MCP server. I know someone made one. These are not the ones I was thinking about. Other people have made these. I have to go find because it was a buddy of mine that made it. And I don't remember what his GitHub username is. Let's see. Most of these we've actually already covered because the guys over at Bad Sector Labs, they took some time off because they were focusing on development for the next Ludus release. And so this is like kind of like their backlog for it. But let's see. Anything else that might be super interesting we could cover real quick? That's not from White. I saw this one. It looks interesting, but it's unauthenticated RCE and Net Support Manager. And yeah, it sounds interesting. I don't know if I want to cover it tonight. If it was Watchtower, I would absolutely cover it tonight because I love their blog so much. I've also found it pretty handy if I'm too lazy to spin up a Bloodhound or something. It probably needs some work. Actually, you know what? I would think with some... Hold on, let me bring it back up. Because it had several output options. I think this could be even like a very standard tool that you could just go script into any kind of AI agent if you make it real quick. Yeah, here we go. Because you can export this as Markdown, JSON, or YAML, right? So default. I'm an adult. The default is Markdown, but you go spit this out as a JSON or YAML. Markdown wouldn't be bad, right? So like you can look at the example YAML output. This is not too bad. you still have to go burn a lot of these tokens for stuff like this. I wish you had an example of what the JSON output looked like, but that would actually be something real simple that if you were just wanting to wrap into something in an AI agent also could be handy. The main thing being, yeah, Bloodhound is going to use way more resources than this because of that Neo4j backend. Defarting sounds like something you would find on the paid section of the hub. Two things about that. One, ew. Two, I really hate that I know exactly what you're talking about whenever not just you, but anybody says the hub. I hate that. All right, let's wrap it up there. Let me see who's online on InfoSec streams. Ooh, we actually have some folks on. This is great. Normally this time of night, we're the only ones on. Hang on. So Standard Error, DK, and Jex of All Trades is on. Let me see what they're doing. They're doing Doritos. Dorito Nugs. All I have to say about Taco Bell is, if you were as old as me and you remember Taco Bell from the 90s, go try Taco Casa. That's all I have to say. Go try Taco Casa. Because I found out Taco Casa was a fork of Taco Bell. It was a franchisor who didn't want to go be part of Pepsi, and he kept all the recipes. And it's the only fast food that I'm like, heck yeah, let me go get some of that. And I eat it and I'm like, tastes like nostalgia. Nom nom. Versus something like cereal, where I'm like, tastes like shame and cardboard. Ooh, what is he working on? Hold on. Does he not have any audio? Monkey at keyboard. Nice. What's Jex doing? Jex is doing Popeyes. Wait, who did the 90s throwback? Everything was the same price as it was in the 90s? You're talking like you could actually get like a decent taco or burrito for $1? And I'm not talking about like the Jack in the Box craptacular ones. Oh, Taco Bell did? I still don't know if it's worth it, man. Taco Bell just tastes horrendous these days. Note taken, if I get off the travel ban list when I go to the US, I'll try it. Yes, definitely try Taco Casa. And until I learned that, I didn't realize how many Taco Casas were like around me. Jex is over here playing Just Chatting. This doesn't look like Just Chatting. This looks like a horror game. Not sure what he's doing. All right. I think we can probably find somebody else doing something cool, technical. Like Zed's on right now. We could go see what Zed is doing. Here, let's see who's online right now. Who do we have on? Who is in the same category? Let's see. Moo Hoodies is always on. And I love her space stuff that she's doing. Round 2 of a motor versus a brain cell. Nice. Let's see. Well, see, Hats, you can't be on the no-fly list because you're a Fed. You're in chat, therefore you're a Fed. I don't make the rules. It's just the rules. If you're in chat, you're a Fed. Let's see. Let's go see who's in... Nah, what do we see? Who's over in software and game dev? That's the wrong button. Let's see. Adam's on. Zed's on. What's Adam working on? He's doing a Steam playtest demo. Zed's doing some more C++. It's always fun to watch him doing C++ coding. He does a really good job of it. Who else do we have on this doing anything fun? Wait, is this guy actually working on open code right now? Why is all my audio not working? I don't know why I'm not hearing anything. Jitspo's on? Let's go check. See what we can find over to. What's he working on tonight? Oh, he's working on his Godot game. Yeah, you know, we'll go right over to him. He's always up for a good time. All right, guys, I got to wrap it up there. Thank you all for coming to hang out, covering the hacker news. Apologies for being late to the stream. I don't know why I was so freaking exhausted, but I had to catch a nap before the stream, and I just overslept. Everyone, take care. Y'all have a great rest of your week. Crushing It mode is still in full effect. It does not end until Friday when you clock out of work. There you go. Remember, Friday is read-only Crushing It mode. You're going to prepare for how to crush it on Mondays. That's what I want y'all to do. Everyone, y'all take care. Have a fantastic night. Thanks for coming to hang out. I love all your heckles and your ideas, especially about pinning the content, whatever like we're talking about in the chat. I will start making an effort to make that a constant thing because I like that idea. I want people to be able to go follow the articles as we're going through them. So, everyone, y'all have a fantastic night. I will catch you on Saturday. We'll keep working on the Mythic MCP server, getting that all baked up so we can start working on the post-exploitation agent. Let's see, is there anything else I got for you? I think that's it. Wait, I forgot. There is one very important thing, and I want y'all to remember this, and I will catch y'all on Saturday, but that is, I love you. Peace.